sit or do they stand? What do I do with myself?
Whatever you like. Whatever you're comfortable with.
Okay, if I get really excited, I'll stand up.
Yeah.
How about that? I do. When it comes to restoration, I do get really excited. But I don't think I've ever been able to give a presentation sitting down, so like, I'll take advantage of this. Just relax. Some things I might have to read from my notes, and I apologize in advance, but Bruce, who wasn't able to be here, who asked me to come in and fill in for him, sent me some slides kind of at the 11th hour, and I threw in some of the information, but it's not mine. So if you see his name at the bottom, those are probably the slides that like I might not be able to answer your questions, but I can write them down and ask him. Oh yeah, I got one with my little thing. All right, well thanks Kate for the awesome introduction. That was really long-winded. I'm sorry, it didn't seem that long when I was like writing it, but there's a lot going on. I get bored really easily, so I just kind of like switch and jump around from different ecosystems and really just try to understand what else is going on. But yeah, so I noticed in y'all's office in the Golden Hour Restoration Institute that this image is on the wall. And I was like, what a small world. Like right when you walk in, you have the Willamette LiDAR imagery. So let's get started. So an outline, I'm going to go over what is restoration, why do we do what we do, urban streams coordination support. So again, as Kate mentioned, I'm the urban streams program manager for the Marin Resource Conservation District. So I'll talk a little bit about my role there. I'll touch on permitting. I understand that you guys already had a lecture on permitting, so I'm not going to beat the dead horse. We'll just cover it. And with my experience, everybody has got a different experience when it comes to permitting. So I'll share my experience, and then some case studies of small-scale restoration, large-scale restoration, and touch just a teens on politics. I really wanted to build that section more, but I ran out of time, and then go over some resources. Really quick, how many of you guys are familiar with RCDs, Resource Conservation District? Cool. Okay, nice. So they're born out of the Dust Bowl. So when the Dust Bowl happened, NRCS, which I guess at the time was like U.S. Soil Conservation Service, they ended up having a hard time working with the farmers, and the farmers wanted, they didn't want the big government, they wanted help, but they wanted something a little more localized and more fitting to their needs. And so resource conservation districts were born out of that. And in California alone, and sometimes the name changes depending where you're at in the country, but in California alone, we've got 98 RCDs. At least last time I checked. I used to work for the Coastal San Luis RCD and State Parks down in the Pismo Dune complex that Kate mentioned me being down in. So at the time there's 98, and some counties have one, some counties have two. Mm-hmm. Sonoma County used to have three, we now only have two. Marin County, we only have one, and we don't actually cover all of Marin County. So just because it's in the county doesn't mean its jurisdictional boundaries are all over the place. And so with Marin, we're focused mostly on Western Marin and Northwest Marin. And so RCDs are really born and formed around meeting the needs of the local farmers and agriculturalists, and it just depends on the needs of the watersheds too. So in Humboldt, there's a lot of work going on with RCDs around water quantity and cannabis cultivation, restoration, remediation, stuff like that around water quality issues. And then Mendocino, a lot of logging roads, and trying to clean up the logging roads, decommission the logging roads, so a lot of sediment issues going on there. Sonoma County, obviously, water issues around vineyards. Mm-hmm. And then in Western Sonoma County, there's the Goldridge RCD, which I love those guys. They're so awesome. And they work a lot on water rights and fish passage, and a lot around coastal salamonids, endangered salamonids. So I'm like their biggest fan. And then the Marin RCD, before I came about, we focused on dairies and ranching and a little bit of farms. There's not a whole lot of farms. There's only a few vineyards, so it's really like ranching and dairies. And then there were some issues around a stream conservation area ordinance and having a riparian buffer and a setback for like any kind of proposed activities that are near a stream have to be set back. That became really contentious in Marin. Is anybody here from Marin? I should ask this question. Mm-hmm. All right, you are?
Fairfax.
Okay, cool. Fairfax. It's like the cool place.
Yeah.
So in Marin, that became a huge stink, and actually a lawsuit came out of it. And so because of that, the county was like, oh my gosh, like what do we do? Like we need to hire someone that can help the residents go through this process of the stream conservation area ordinance and hold their hand through it. and it has to be someone that's neutral because there's so many contentious issues in Marin, and everyone's kind of like in the middle of suing each other, or they're not communicating. You know how it goes. So the RCD happened to be really neutral because we don't really get involved with a lot of those issues. We stay, focusing on farming and ranching. So they asked the RCD if they wanted to hold this position of the Urban Streams Coordinator, Program Manager, and RCD said yes, and I was born. And my program actually does cover all of Marin, so I don't have any jurisdictional boundaries other than the county. And then sometimes I get to like sneak out of the county and come to situations like this and opportunities to speak and teach, and gets me bouncing around California a little bit and not being so stuck in Marin County, which isn't an awful place to be stuck, for the record. And do I have any questions? Yeah.
Well, I'm just trying to understand it. You said it was set up in the Dust Bowl to provide resources to farmers,
Yep.
starting out with soil issues, obviously. And you said in Marin it's farmers and ranchers, but then Marin County asked you to be in charge of this riparian thing, so local counties can say, this is our need, so can you do this too? Is that how it happens?
Pretty much.
Okay.
They wrote a proposal and submitted it to the RCD and said, we'll give you this amount of money if you will hold this position and you'll manage it. So like I don't have to answer to the county, but I do have to beg them every 2 years for funding because it's a 2-year contract.
Okay.
So they had the contract with the RCD. And yeah, I mean, in the past, and as far as like ranching and dairy needs, a lot of it's been like methane capturing, fencing out, exclusionary fencing, keeping cattle out of the riparian corridor for a ton of reasons. Really working on pathogen reduction because we have a lot of pathogens in small space, a lot of that ag land there. We have a lot of runoff that's including a lot of fecal coliform into the water. And obviously we have shellfish, we have a lot of oysters and clams growing there and mussels. So that's become a big issue, especially with the Regional Board and Clean Water Act. So our past has been focusing a lot on that and repairing gullies. I hear you guys already learned about erosion. That was my favorite. I mean, I don't love erosion, but I really love the subject. It's so fascinating, land process season.
You can talk about it. We didn't go super in depth in it.
Not too deep? Okay, cool. I really love learning about erosion and talking about it. So yeah, the RCD has focused a lot around erosion stuff. So yeah, they just wanted to find someone that was neutral. And believe it or not, like at the time that the county kind of surveyed all the different groups, the RCD was the only potential group to like have this great outstanding relationship with private property owners, and the position is specifically working with private property owners. So yeah. All right, restoration. So the return of a degraded or former system to its pre-existing or naturally functioning condition, or a condition as close to that as possible. Obviously, everyone has a different definition of restoration. I'm sure you guys have heard a lot around that, but there's varying levels of restoration as well to what degree you're going to do it. So, a lot of other words that I hear and use. Sometimes people think they're interchangeable. I'm going to kind of try to separate some of them, but there's restoration, rehabilitation, reclamation, mitigation, naturalization, habitat enhancement, enriching of resources. But the overall goal is to restore the function so that each watershed may allow for the overall processes to be revived. Reclamation, it just sounds negative to me for some reason, but I think it's just because of like thinking of the different projects that are reclamation projects. It's like taking a completely denuded, blasted landscape and trying to just get it to function on some level. So I saw a definition that sounded about right to me that says partial restoration of specific but not all functions of the original ecosystem, and typically used to restore processes that destroy natural ecosystems and convert them for ag or urban uses. So one example that I saw was constructing a pond for groundwater recharge that also includes the potential for natural recruitment of wetland veg. But when I read that, I'm like, it's really a potential vector for invasive species to come in, because once you start disturbing the landscape, the invasives are like, ooh, thank you, thank you, thank you. And depending on your equipment, if it's not cleaned and properly addressed, then you're bringing in a lot of invasives. So rehabilitation is really where I feel like I spend a lot of my work doing, and it's partial restoration of underlying natural processes to produce a cascading beneficial effect of restoring ecosystem function, which result in improved ecosystem structure. So it's putting things back in good condition and in working order. An example for that, talking about the pond again, just keeping it consistent, constructing a pond for groundwater recharge, but actually actively planted with wetland vegetation and large woody debris for multiple species habitat and nutrient cycling. So really thinking more on a multi-process approach. And then restoration, full-blown restoration, all of the ecosystem function structure brought back to the original state. And then I saw something about creation, bringing into being a new ecosystem that did not exist before. That sounds really scary to me. Like if you're just like, poof, I'm just going to create this whole new ecosystem. I'm curious about any practitioners that have done that and how that worked. But anyway, so how many of you guys think that in the Bay Area that you could conduct true restoration? That's a nice response, yeah. We're focusing more on rehabilitation, like what can we do to get some of the processes going and a multi-benefit approach. So in most cases today, due to climate change and water and or land use stressors, we can't really do true restoration, especially in this urban environment. But a lot of the work is, just again reestablishing pre-disturbance functions related to physical, chemical, and biological linkages between aquatic and terrestrial ecosystems. I'm not going to read from the screen. That's never exciting, but I'm sure you guys have read that by now. I want you to also to know that you can interrupt me anytime, or like do this or something. And if I'm like finishing a topic, I'll just like finish the sentence and then holler at you. But I'm really open and easygoing, so just jump in anytime. Yes.
Yeah, I'm wondering if you have any information about restoring maritime chaparral, because I'm working on a project that was former maritime chaparral where there's an endangered pallid manzanita.
Mm-hmm.
And we've had a series of lectures about riparian systems, like maybe 4 in a row. And I don't know if we're going to get to other types of habitats, but if you know anything about, because maritime chaparral needs fire, and no one's talking about fireboxes or fire or
control burns.
Watch
out for those words. People get all freaked out.
Ways of doing it without using any type of fire. But I'm just curious if you have done any chaparral restoration or any.
I haven't, but I'm going to write it down just to know, because I do have friends and colleagues that work in that world.
Mm-hmm.
My topic for today on the shard was like riparian system processes or something. So I was like, all right, this is going to be very riparian.
Yeah.
But I do, my former advisor and one of my really good friends is like total chaparral and restoration guru. So I can put you in touch with her and see if you can get some of those questions answered. But it's a challenge.
Yeah.
You need fire.
Yeah.
But we still have a long way to go with education and getting people comfortable with the idea and concept of control burns.
Mm-hmm.
All right, so why do we do restoration? Historical land management or lack thereof. I mean, we really haven't been the best land managers in the past, but it's all about education and learning, learning from our mistakes. And I really love this quote at the bottom. The acid test of our understanding is not whether we can take ecosystems apart on paper, but whether we can put them together in practice and make them work. Which is quite timely with acid tests and thinking of being in Berkeley, but I just really enjoyed that one of, how can you put it together and just make it work again? And there's a lot of different reasons for restoration. So, like I said, with the land management, and historically in Marin, logging and grazing began in the early 1800s, and the dairies came in the mid-1800s, which meant a lot of vegetation was being cleared and led to a loss of habitat and a massive increase in erosion. Luckily, the Clean Water Act was stated, and so that's really helped regulate a lot of activities around waterways and being able to have better water quality. How many of you guys have heard of the Porter-Cologne Act? Okay, a little bit maybe. All right, I'm not going to dive into it, but it's just it's the state version of the Clean Water Act. So
What's the name of it? What's the name?
Porter-Cologne Act.
Okay.
Really weird.
Cologne a person?
It better be.
Porter-Cologne Act.
Yeah, because that doesn't help water quality. Think
sad.
about a bunch of cologne in the water. Yeah, I'm sure it comes from something. I haven't done the research on like where that came from. I just know that if you aren't, we'll talk about this a little bit with permitting, but if you don't have the nexus with the Army Corps of Engineers, then it's not going in the route of Clean Water Act. It bounces back to state and goes through the process of the Porter-Cologne Act.
No,
But
okay.
it's our state version of Clean Water Act. So, destruction from development. I mean, I could go on for like 3 hours on how development has impacted our watersheds, but I'm sure you guys are already very much aware of that one, between housing and businesses, transportation. The SMART train is just a total nightmare right now in Sonoma and Marin counties. Recreation, floodplain loss due to incision, agriculture or development.
What's incision?
Oh, yeah. All right, so incision is
Is the word incision or?
incision,
Okay.
and it's a result of, it's vertical erosion. And so it can be triggered from a sediment-starved system if you have a dam upstream. So it's not allowing sediment bed load to actually mobilize and move and pulse through the system. So the stream will become sediment starved or hungry, and it'll start collapsing on itself and starting to down cut until it hits bedrock. Then it can't go further anymore. But that's when you get in a creek that's really entrenched, and you're standing in the bottom of the creek, and you're like looking up, and the banks are up there, and the water is like, you know, at your feet. So it's when it just keeps cutting and cutting and cutting down. Also, another thing can be urbanization impacts runoff. You have a lot more runoff and permeable surfaces that are sheeting the water off instead of letting it infiltrate. And so when that goes into the waterways, those creek banks they weren't developed or they weren't evolved to handle that much water, that volume. And like 1 gallon of water is 8.6 pounds. So you can imagine how heavy that is. And so that much weight ripping and roaring through a system just really starts eating it down and starting to down cut. And also when you have, you know, when you're driving really fast in a car, and you go on an outside bend, how it kind of pulls your body to that outside. Well, water's like that too. So when you have like a strong curve, a strong meander in a stream, the water's moving the fastest right there on that outside curve. So if you're ever looking at property and there's a house anywhere near an outside curve, don't buy it, because your house will eventually fall in. Like, it will continue to eat away and keep scouring. So scouring is just kind of like the process of the bed load or of your banks, of your sediment material being, you know, eroded away. So you can think of scouring and erosion pretty synonymous. Anything else? Let's see. Development denuding. Yep. All right. Let's move it on. Oh, mitigation. Are you guys familiar with mitigation? Have you heard that? If you do this, you have to do that. They hardly ever monitor it. It's not really. It's awful. It's usually awful. It's not always awful. So another reason for restoration, of course, biodiversity, climate change adaptation. This is becoming really big in the Bay Area for obvious reasons, with sea level rise and just understanding what's going on. And those of you that work with plants, you've probably already heard about Phytophthora, beyond sudden oak death, but the other Phytophthora species that are now coming in through the nurseries and really kind of taking over our wildlands and they're getting our native plants. So a lot of restoration nurseries are having to get so particular with their best management practices to try to keep it out. And of course, restoration aesthetics and health. I mean, you know, it looks so much better than a denuded, awful rock line or cement line channel, you know, when you actually get to have the trees and the fish and the birds and the butterflies around. You just really get to enjoy and be at peace with that. So another reason for doing restoration, here's a good example. This is from Bruce that he sent me. This is, on the left, it is your historical extent of riparian and wetland habitats in the Sacramento Valley. And here it is now. So that's, you know, a massive decline. And so that, for me, when I see stuff like that, I've got job security. You know, I'm just like, man, I'm gonna stay working for a long time.
What's the year that the pen to the lower left?
This is 98.
So, well, it's historical. So it's 98 that the report came out. The report came out in 1998.
1850 or 1880?
Let's see if Bruce gave me that slide, and I didn't see.
I'm glad you brought that up because I thought it was just 20 years, and I'm going,
yeah,
oh my God,
no,
how could that happen?
That's really depressing. No, I'm sure that's something I would say from like the early 1900s, but I'll double check on the date with that one with Bruce.
Because they were already building dams by the 1900s.
Oh yeah.
Well, they built all those levees up there.
Yeah, and that's
I'm
what
not
really
quite
did
sure.
away.
I'm not quite sure when they built them, what decade it was.
Before the Shasta Dam, they had done a lot of work actually. But that was sort of the big killer to stop floods going forward.
Right, because everybody wants to live in the floodplain. It's a great idea, right? Yeah. Let's train the rivers to stay away from us so we can live on the floodplain. So fine sediment is a really big impediment for water quality, and I put fine, really tiny, because it's tiny. It's like the clay, it's the silt, it's, you know, the stuff that, you know, what we don't like about it. Because I really love, erosion's good, it's a natural process, right? You know, things are just going to erode, they're going to break down. But it's the fine sediment, it's the silt and the clay that is actually a really big impediment for water quality. And the reason why is because once it goes into the system, and this is from, you know, a lot of incision bank failures that occur. There's a lot of different reasons you get it, and we'll talk about that. But fine sediment is bad because it suffocates salmonid eggs, or any fish eggs, any aquatic organism eggs. But specifically, I'm a nerd for endangered salmonids. I work a lot around coho salmon and Chinook salmon and steelhead trout. And when they lay their eggs and they build these nests called redds, they clear out the gravel, so they need like the right size of spawning gravels to be able to spawn. So that's why I really, like the bedload to be moving and like the geomorphic processes to be occurring, so that way the salmonids have spawning gravels. However, when you have a lot of fine sediment, it fills in all the interstitial space. It makes it harder for them, as well as it can come in and just like land on and in between the spaces, suffocating the eggs, because the eggs are underneath the gravel, but that gravel has an extra interstitial space to allow for oxygen exchange. So once that fine sediment fills in all those pores, they suffocate and they die. Not to mention it getting into the gills of the larger fish. It makes it hard for them to be able to find food because they can't see. It also makes it hard for them to escape predators because they can't see the predators coming. But it also helps because predators can't see them so easily. Like lamprey fish, they will, I guess it's debatable who you talk to, whether you consider them a fish. They're really prehistoric creatures. But when they spawn, they actually come up during the night in turbid waters, just to kind of be more low-key and hidden. But anyway, so those are the reasons I'm not a huge fan of fine sediment. And so how do we get the fine sediment? And we have roads and trails. So rural roads and trails that are falling apart, trails that weren't built the right way. Of course, back in the day, people didn't know. You're just building a trail and you're making it open. So there's a lot of techniques nowadays on best management practices for building rural roads and trails. Bank failures, and I'm not talking about Wells Fargo. I am talking about your creek bank, and that is like the world that I swim in almost every day in Marin. Is so many people's banks are failing for a lot of different reasons, and it's expensive. At the end of the day, most bank failure projects are anywhere from $100,000 to $250,000. So, and then on top of the fact of how expensive land is in Marin and how much just washed away, I mean, it's really heartbreaking when I go out and do site assessments and see like how much of someone's land is gone, and the fence post, like part of the fence will still be hanging there, and you can see how much is gone and has retreated. But a lot of that, a lot of fine sediment input just happened right then and there.
I'd like your references on new rules for building trails.
Oh yeah, so
because I'm working on some projects where we're trying to redo trails.
Yeah.
So there's less erosion.
Write down Pacific Watershed Associates.
Okay.
I'll add that to my resources slide if it didn't.
Pacific
Watershed Associates. So they are kind of like the gurus when it comes to rural road and trails and building them and doing the best management practices around that. And they have a new handbook that is revised and updated for nowadays, and it's for free on their website.
Okay.
And it will give you more than enough to chew on. And it's really fascinating because it kind of gets into erosion.
Oh, great.
My favorite. Okay, so sediment-starved systems. Fine sediment, again, like I said, if you have a dam upstream and the stream downstream of the dam is hungry, it's wanting to replenish, it needs to move. You have your upper watershed, it's a more cascade system, it's steep, the water's moving fast, you have more boulders, you have big rocks and cobble. You move on down in the watershed where it's not so steep, and you're getting more of the spawning gravels, you're getting more, the cobble and the gravel, and just some nice, a nice mix right there with your bed load. And then as you work your way lower into the watershed, then it starts flattening out and you get your valley bottom. The water is slower, so when your water slows down and typically your stream banks are going to widen out, the sediment drops out. So that's how you get your alluvial fans, right? Your deltas are happening right there. However, sometimes it just starts degrading and building up, and so people that live in valleys, especially in Marin, they're like, oh my gosh, I'm going to be flooding. So if things degrade too much, the channel doesn't have the capacity to hold the water anymore, especially when you have all that runoff. You've got that much more water, and then you have your channel that just keeps building up and stacking up with sediment.
What is the word on the street from all the sediment that came from the Oroville Dam?
I don't know. I'm so curious. Like,
People
that looked
have
like
to
a
be
nightmare.
talking
Oh
about
yeah.
it
Yeah,
somewhere.
I bet if you Googled it, I wonder what would come up, because I was like freaking out looking every day at that, because I used to work in the Yuba River watershed, and I was like,
so much control, try, and then
You're talking about the Oroville Dam?
Yeah.
And the salmon eggs that they were trying to rescue?
just all of it. Yeah.
they were warned. I mean, I used to work for South Yuba River Citizens League, and my boss, Gary Reedy, the science director, had told them, like, your emergency spillway is an earthen dam. Like, seriously, like, you put this much money into your reservoir, you're like providing the service for this many people, and you have an earthen dam. Like,
And they're down slope
Yeah.
population's downstairs.
I mean, there's just and they never really thought about using it, so it wasn't even planned out right. It was just really awful planning. So remember, plan for the worst, plan for the best. Just plan. Think about every possible scenario before you go into a large scale project and spend billions of dollars.
But this plan, fund.
I know. Planning isn't always the fun. And just remember there's adaptive management, but plan for worst case scenarios for the just in case, so you have your buffer. Overgrazing is another reason for fine sediment. I've got an image that I'll show you guys for that one, and then development, as I mentioned. So TMDL, have you guys ever heard of the term TMDL yet? Okay, so you guys are, yes, some yes and some no. So it means total maximum daily load. It's a regulatory term in the U.S. Clean Water Act describing a plan for restoring impaired waters that identifies the maximum amount of a pollutant. Specifically for Lagunitas Creek, where I spend a lot of my time in West Marin, it's fine sediment. And so it's the maximum amount of a pollutant that a body of water can receive while still meeting the water quality standards under the Clean Water Act. And so then it becomes listed as a 303D listed impaired waterway. So if you type in 303D listings, California watersheds, you'll see all kinds of different reasons. It could be mercury, it could be sediment, it could be pathogens, it could be selenium, like San Francisco Bay just got the basin-wide plan just got amended to include selenium, diazinon. So there's a lot of different, a lot of nutrients too that will be included in that. So this is a great example of an awful road. This is at San Domenico School in San Anselmo. I'm working with them diligently, trying to find some ways that we can alleviate this. You can see formerly they had someone that wasn't sure what to do about it, and they just threw gravel in there. Well, it's really steep, and so when it rained, the gravel washed out. And gravel is actually kind of expensive, so that, if you go to the bottom of that hill, is where you will find the gravel. Their next proposed action was to fill it in with a concrete slurry.
Oh no.
And I was in water bars, and I was like, hey, late 80s called, they want their techniques back. We don't do that anymore. That's just not the way it works. And it's not going to hold, because if you imagine filling that in with cement, right? If you had just one little nick point where the drops of rain start going into, it's just going to come unraveled. So, and that proposal.
And it also increases the velocity of the water.
Oh yeah.
Lower down the hill.
Yeah, no roughness and no way to permeate.
Yeah.
Yeah. So it's that proposal was like $200,000. I was like, what? You're crazy.
To pave it with.
This is Dominican
To-
College.
Yeah, San Domenico. It's a private school. It's like K through 12, I believe, international as well. So luckily they're open to some ideas. I've turned them on to the Pacific Watershed Associates handbook. I'm like, you guys need to be doing this. So there's different techniques. Like, I won't get too much into it, but there's something called rolling dips. And so about every 100 feet, you would install a reverse grade dip. And so what it allows is the water can only come down 100 feet, and then it's going to sheet off. And it's going to come down another 100 feet. And so it never actually gets to the point of increasing velocity to a point where you start having these rills that then go into gullies, and you get the trenches and have to start doing check dams and trying to fix them. And here we can't do check dams because this is actually a fire road. It's a trail, but it's also the fire department uses it for emergency reasons. Of course, I wonder if they can even get their truck up it, but they're willing to throw in some money to help find some long-term repairs for it. This is an example of outside bend. Flow's going this way. Here's the outside bend. It's been eroding and eroding. And it's too bad. It's kind of dark, but
Really hard to see it.
yeah, right here. Here's the end. I'm going to stop shaking coffee. All right, here's the end of the bank. Here's the end of the house.
Oh wow.
That much is hanging off over the creek. This just happened this last winter. This is in Fairfax.
Says High Creek washed it all.
Yeah. High flows came up, scoured and just retreated us, because I saw this guy last year and I didn't even think about that house being, I thought like later is going to be an issue, but I didn't think it was going to happen in the next winter. And he ended up having to do an emergency project, and we'll talk about that in a bit, but that was a mess. And so he just got that repaired. And then here's another example of the wonderful bank failures in Marin. This is over at White Hill School in Fairfax. And this is over by their track field. And here's their normal pathway. So it kind of became a safety hazard for students. Here's like the old lining there. So yeah, it's a big hole. And it just slumped. So here's the water down here. And it just went poop. And for the most part, it's pretty stable at the toe, which is what I really look for, is if it's going to keep going out and collapsing, but kind of fell on itself at a nice angle. So I haven't been too concerned. I'm working with him he only needs one permit to deal with this. And then we're just planting it. Saturation, development, I mean, you can see there's a lot of pavement.
More compaction, not good grading. Blah,
Yeah.
blah, blah.
Yeah, a lot of runoff is going on, and it's Fairfax. I mean, this watershed, as you move around throughout it, is pretty incised from development and just other land use practices, but for the most part, it's from development. And so, yeah, I see this every day, and it's really heartbreaking when it's actually on someone's private property and they're retired and they don't have money to fix it. 'Cause like I said, it's $100,000 to $250,000. This is what I see all the time. So this is an incised creek. This is a sheer vertical bank. So I've seen worse. It's not too bad. It's fixable. But as you can see, there's only one tree. And if this were planted, so the toe is pretty stabilized, looking at these willows here, that's nice. But if they actually plant it along the top of the bank, it's a lot more likely to be able to hold that in place and not dealing with that. And guess what happens? When the waters rise and start scouring this away, what is the input that I don't like?
Silt.
Yes! Fine sediment! Itty bitty sediment! Comes right off and goes right in.
Are there also issues, because my mom lives next to Manor School, in some apartments, and I think she said there were 12 landslides over the winter there. Are there just issues with the banks there, or is it really the development along there?
So
It's all the undercuts.
it's all of the above. Well, it's all of the above. So in Fairfax, they've built on top of the creek,
Yeah.
as you notice.
My
And
mom's house is on the
yeah, it's really
creek, or
heartbreaking.
apartment building.
Right.
Yeah.
So they built on top of the creek, so they really end up trying to control it and train it. And so then when you have these narrow areas where it's in underground, it's in a culvert. When it comes out, it's usually like a fire hose, and so it just causes more and more gesundheit, more and more incisions, as well as geologically, it's like the valley formations, like what we have geologically in Sonoma and Marin is like butter. It just easily erodes. So geologic conditions on top of development, on top of runoff, it's just all of these confounding factors where it's just it doesn't stand a chance, and it's really heartbreaking. And in Fairfax, I'm sure your mom is very aware of all the flood control meetings, and everyone's fighting. They're trying to find ways of getting less water in the channels because it's just too much.
Yeah.
And it's causing a lot of different issues. So here's an example of, again, just development right up on the creek. This is actually in Fairfax. And here's a house right here. That's the top of the bank. So talk about incision. Top of the bank, here's the water. Bam. I mean, it's pretty vague. But back in the day, everyone wanted to live on the creek. It's romantic. It's the babbling brook. It's really cool. It's not cool anymore. And most places don't permit it. And if you don't have a house on slab foundation, I'm now trying to work with the county and private property owners to elevate and move houses back away from the edge of the bank. It's which is really expensive. But if you're on a slab, you're just wait till your house falls in. Pretty much, it's not really feasible to financially afford moving a slab-based house.
So the ones that are out there elevated on piers, like sunken piers and raised piers both?
So a lot of the repairs on this house, that's what they ended up doing, was sunken piers, because he's on a slab, he wasn't able to move it, and so he ended up doing the heliocoil piers going down, and then filled in this area with rock, which my feelings about riprap and rock is about right there with fine sediment. I'm not a fan. It's a tool that can be used every now and then, it's necessary. Yeah, when it has to be used, I totally get it. But just to be no, I just want a bunch of rock on my creek bank because it's safe. And because in the 90s, that's just what we did. And it's an old practice, and it ends up causing more issues later on down the road. Mostly because it speeds up the water. So then you have higher velocities, which means, more passage barriers for fish. It also is faster water ripping and roaring through and eroding the creek banks, causing further vertical erosion or incision. And also, it's angular, so it's not always aquatic species happy. For the most part, there's not vegetation growing, so you miss out on all the advantages of canopy cover that we'll talk about. And it's typically white and a lighter color. And have you guys heard of albedo, the albedo effect, reflectivity? So it reflects and can heat up the water. So that's another reason that I'm not a huge fan
You're saying like rocks will do that?
Yeah, the lighter color, they reflect it. They reflect the
Lighter.
sun, and it ends up increasing water temperatures. So that's documented by Army Corps of Engineers, believe it or not. They're like super rock heavy, but they're learning. They're getting there.
Does flood insurance cover these different homes, or is that just for people who live on the ocean?
Nowadays, I don't think you can get flood insurance for like if your house is that close.
Oh,
But if you already had it when you moved in, yes.
Okay.
It depends on, you have to look at the FEMA flood maps. So, and they just revised theirs in the last year or two. So you can go into the FEMA website and then look, and then it'll tell you what kind of coverage you can get. So another reason that we have, sediment issues and erosion is this. We have dams. I already talked about this a little bit, so just really getting into the sediment starve system. Oh, this is what I wanted. There's something really cool about this one. So this is on the Carmel River, and this is just in the summer of 2015. Hi. So almost the entire capacity of the reservoir was filled with sediment and erected at the confluence of the Carmel River and San Clemente Creek. So the dams essentially blocked 25 miles of prime spawning and rearing habitat for anadromous fish. So anadromous is fish that can go back to saltwater, freshwater, back and forth, including South Central California coast steelhead, listed as threatened under the Endangered Species Act. It also damaged wildlife habitat by starving the downstream river of valuable sediment necessary for fish to lay their eggs and nest or redds. So again, like I was talking about, having that replenishing and making sure that the bed load's able to move and the system can replenish itself. So through a collaborative process, eventually the decision was made to remove the dam, and the challenge for the design team became what to do. I think that's really exciting. So the challenge became, what to do with 30 million pounds of cement associated with 106 foot of the high stone, and there was just a ton of sediment. So someone talked about rerouting the Carmel River above the dam and into San Clemente Creek and around all the sediment, and just stabilizing the sediment in place instead of trying to deal with it, and then removing the dam. And that was successful. So 1/2 mile diversion was not only more economical, but also had the least environmental impact and of any other previously suggested alternative. I know, it's
It
pretty
seems
wild.
like a completely radical idea. Oh, we're just gonna move it over there.
Yeah, pretty radical. But that's the cool thing about restoration is like nowadays, like you can do so many modeling and so many analysis, and you can really like kind of figure out how it's going to look and how it'll shake out.
So all that sediment became like the stream bank that they were able to like plant with trees.
So it's now a former channel. So now it's just planted. So it's riparian.
Planted.
Mm-hmm. Yeah. So they rerouted it completely around
It's
there.
not a river, it's a landscape.
Yep. Now it's landscape. So the dam removal and rerouting of the Carmel River began in 2013 and was completely finished at the end of this year, which was last year. And the cost was $83 million. That's not cheap. I can imagine writing a grant for that one. So this is an image. So I was talking about overgrazing being one of the reasons that we have fine sediment as a pollutant into our streams. And this, as I understand, you guys did look at, hear a little bit about erosion from NRCS. So the rills became the gullies, and now there's just like this gaping wide landscape. I'm not sure where this is taken. This is not Marin. Luckily, I couldn't find anything that looked this bad for photos in Marin, but we definitely have our fair share of gulls and willies that are going on and allowing fine sediment
And is
input.
that because of soil tap, or is that because of grazing makes the vegetation not be so feisty anymore? What is it that?
Typically, when you're ranching, you clear a lot of vegetation because you want more forage, you want more forbs for them to be eating grass and forbs instead of like trees and shrubs. So your land management practices are, unless you're doing silvopasture, which is a practice where you actually allow the trees to grow and the cattle to be there in harmony. But that's more of like a newer practice.
That's the word is civil.
Silvo, S-I-L-V-O, pasture.
Okay.
And so not only do they do a lot of vegetation clearing, but there's the lack of consideration or lack of knowledge and understanding over how many animals to have per acre and how long, not giving it a break and just having animals there full-time, year-round, and too many. So just all the compaction. And then again, if you don't have exclusionary fencing set up around your riparian corridor, then they're getting in and out of the creeks because that's their water source. They're trampling all in it, and they're mucking it up, and then again, there's also the pathogen water quality issue too that comes into play. Okay, so another component of doing riparian restoration and why we do it is invasive species control. Did you guys already have the talk with the invasive plant council? It's Phillips? Okay, cool. So you guys are down with this. So these are my top invasive species that I have to be aware of within my position is Japanese knotweed. I'll talk about that in a second. It's awful and it's new. New Zealand mud snails is an aquatic invasive species, and it's right here. It's so tiny.
Mm.
It's just like that fine sediment I was talking about, so tiny. And it can, so, kids want to go playing in the creeks, people want to go tromping around, or even if you're, a practitioner and you're newer and you don't know about aquatic invasive species, you get out there, you're doing monitoring, you're doing maybe, a pebble count or something, trying to understand your bed load, and then you go to your next watershed, and then you go to your next watershed, and you're not even thinking about it, and it's on your boots. So that's how they get around, and they're everywhere, but how they got introduced was on the ballast of ships. And so now if you ever, how many of you guys have gone to Lake Tahoe on a boat and you have the boat inspection people are over there and they're checking out everything. So they're really trying to be
They don't do the little
better
tiny
about
boats,
it.
they do the bigger boats.
Oh, really? Only the bigger ones?
Yeah.
Okay. That's a little disconcerting. Because
There's
how
a
long
lot-
ago was
there's-
that? Because I went like maybe
There's
5 years
a lot of
ago.
education being done about clean your boat, clean your boat, clean your boots up there.
Yeah, maybe they ran out of funding for actually having staff to look at every single boat.
I did a project for Keep Tahoe Blue, so that's the only reason I know.
Yeah, it's stuck in your head. Yeah, it was about 7 years ago. I went out on like a smaller speedboat, and it was actually one of my friends from high school in
Anything
Georgia
with-
that was the
anything with a
inspector.
mo-
I was like,
anything with a
small
motor
world.
checking.
Yeah.
Anything with a motor.
Okay, there we go. Yeah, it was on a little motorboat. So yeah, that's a really nasty one. And in Marin, it's in our bay draining watersheds in East Marin, but so far we don't have it in our Tamales Bay draining watersheds. So for the people that work in Marin around watersheds, we typically have separate gear. We have like East Marin monitoring gear and West Marin monitoring gear, so that way you just don't confuse it, don't get it over there. If you do have to, monitoring gear is pretty expensive if you can't afford a second set. A lot of the basic rules around your protocols for cleaning them is you can use a bleach solution, like 5% bleach solution with a brush, really clean your gear. You can also freeze your gear overnight, so like 24 hours of freezing, or complete desiccation, like 48 hours of desiccating. You don't always have that availability of time though if you're going from one stream to the next. So there's other decontamination solutions that I've seen when I've gone out doing California tiger salamander monitoring that you can do like on the spot going from vernal pool to vernal pool. English ivy, heterohelix. I don't use the H word a lot, but I really hate this plant. Like it's awful. I've yet to find a single study that actually has benefits for wildlife. At least Himalayan blackberry, I'm like, oh, it's good for nesting songbirds. It's got fruit for the fructivores. Not that I'm saying I like Himalayan blackberry, but I can handle it. But English ivy is a totally different ballgame because it'll go up the trees, the riparian corridor, strangle it, kill it, and then people, I'd be like, you really need to cut that at the base of the tree and get rid of it. And they'll be like, oh, but it's like privacy. Like my neighbors can't see me and I get to like hide out behind my ivy. And I'm like, oh, you're gonna love it when it kills the tree and rips out your whole bank. You lose a chunk of your land and you have no privacy. Like, let's remove it and we'll talk about some native vine alternatives for you.
Don't rats like the ivy?
Yeah,
Love it.
that's
Okay,
the
so
one.
so that's one benefit.
They love
It's one
it.
benefit.
If you consider that a benefit.
They-
I mean, I do
They do
if they're native rodents for sure, but for homeowners, I love throwing that out there because I'm like,
Yeah.
it doesn't support anything except for rats, and then
Yeah.
you're like, oh, and I'm
Well,
like,
there's birds who eat the fruit too, and they pollinate, they spread seeds.
right, and they're usually non-native birds, and so that's what I've seen from Tahoe National Forest studies is because I've gotten into arguments with different consulting firms where like the principals would be like, it supports birds, and I'm like, non-native birds, and I like try to go find like studies where I'm like, maybe.
You can watch robins eat them.
Okay, that makes me feel better. Thanks. Except for the fact that yes, they go coop it out and spread it. And then we have our wonderful broom. So our Cytisus scoparius, the Scotch broom, and then the Genista Monspeciulana, or French broom. And Marin specifically, we have French broom. But a lot of my life up in the Yuba River watershed was controlling and dealing with Scotch broom. It's really flammable. It's toxic for herbivores, and it hosts a bunch of ticks. So keep your possums around because the possums eat like. I wish I could remember the number.
They eat broom?
No, they eat tons of ticks.
The ticks?
They eat so many ticks. Like, it's ridiculous. Like, I'm getting my decimals off. It's either 50 or 500 a day.
Well,
like, they're massive tick eaters.
Oh, wow.
Yeah.
We
Okay.
did
Oh.
in
Oh.
Garber Park for those who were out there for the walk last weekend. There's a little English ivy project we've been working on, and it's had phenomenal success.
Nice.
That said, when you look at the amount of hours that's gone into it, it's been a lot of volunteer hours. It's been people's backyards, so a lot of revisiting.
Yeah.
It's a lot of work, and we're what we've done is we've created the donut hole in the middle
Nice.
in some ways.
Oh.
So
good.
yeah, it's
The
been
beginning.
positive, but
Yeah.
it's a really tricky one.
It is. It's something that, like, for me, I find when I go to homeowners' places and they're like, and they actually aren't trying to keep it for, privacy, and they're like, I want to get rid of it, but oh my gosh, I'm like, yeah, it's daunting. I was like, start, like, delineate your area. Start with one space, and then as you remove it, do your erosion control, because as you're removing invasive species, you are destabilizing the substrate, right? So you want to do erosion control, and then in the fall, make sure you're going back and planting it, so that way your natives can outcompete any of the seedlings or any of the sprouts that would come back up because of the seed bank. Of course, these typically spread by runners, and then the seeds just kind of spread through the bird poop. But that's a really big one, is just section by section when you have a lot of invasive species removed. That way you don't get too overwhelmed. So Japanese knotweed. Have you guys heard of Japanese knotweed, Phillips japonica?
No.
Oh my gosh,
It's in the east
It's-
a lot.
terrifying.
East Coast.
East Coast.
Yeah, up in like New Jersey, the Northeast. Yeah, I've been working with the National Park Service about it. I wasn't aware of it. I had them call me up and be like, "We keep getting Japanese knotweed it's washing down from San Geronimo into our property in the Point Reyes seashore, and we're tired of paying to treat it when it just keeps washing down. You need to go fix this problem." And I'm like, so by the way, the RCD's policies, we help those that ask for it. If you're not asking for our help, we can't tell you how to manage your land. If you want to know how to manage your land, ask us and we'll totally give you free advice. But otherwise, I can't go knocking on doors and being like, "Excuse me, you have Japanese knotweed, you have to get rid of it now." But it's awful, and I'm working a lot right now doing education workshops, trying to get the word out in San Geronimo Valley about it, because it's a whole nother lecture about the issues in San Geronimo Valley with people and relationships. They don't all get along. There's a lot of mistrust. There's been a lot of lawsuits. And because of that, I can't just go out there and map it. I have to get permission from every property owner to get onto their property to be able to map it. And then to be able to write a grant and treat it, which once they allow me to map it and understand what the treatments mean, then I feel like it's going to be fine and easy. It's just getting their trust and getting them to care, because there's so many issues going on right now in the valley that they're like, "Oh, a plant? We don't care about a plant." The really bad thing about it, though, is it's Japanese knotweed, so it evolved around volcanoes, so it busts up through lava flows, like hardened lava, like dried lava flows. So it goes through driveways, it goes through sidewalks,
It's coming through.
Oh, wow.
Huh?
Coming through the drainage or just straight up through?
straight up through the concrete, straight up through, can go in your house. It's you can't tarp it.
Whoa.
So they told me, they're like, "Yeah, we need to spray with herbicide." And like, I understand tools in the tool chest. Like I said, I got methods, chemical, physical, biological. But I like getting the community together and doing like hands-on, like, let's hang out, let's have a barbecue afterward, and like do, buddy up. However, if you try to manually remove this, it stimulates it.
Oh,
It
no.
likes it.
It loves it. It loves it. So, and it spreads by, like, if you just break off a little piece like the size of your fingernail. Like, I thought English ivy was bad. Like, if you have a node that can resprout. This is like a teeny little fingernail size piece will resprout. And it can go about 23 feet laterally and about 6 feet deep, and it's riparian. So it ends up being an ecosystem engineer, and not in a good way of being an ecosystem engineer. And it can totally replace your riparian habitat and your riparian vegetation. And in England, in fact, if you have it on your property in England, you have a lien put on your property. And then, if you get caught removing it yourself or trying to like discard of it yourself, you can get imprisoned you can get fined or up to imprisonment for doing that on your own. It's like that bad. And now we have it in West Marin. Yay. So
How do they remove it in this valley? For the homeowners who want to remove it there, what do you tell them to do?
I tell them, don't touch it.
Okay.
Call me so I can talk them into the fact that they need to let me get a specialist access their property to spray it. And so I've had to work with National Marine Fisheries Service and be like, okay, we have a coho-bearing stream, we've got California freshwater shrimp, we've got a lot of listed species under the Endangered Species Act. Is this okay? Like, what can we spray that's not going to be, an impairment to the water quality? And so they said Polaris. And I checked in with my buddies at the Mattole Restoration Council. And at the Mattole Restoration Council, that community is in southern Humboldt, coastal draining watershed, beautiful watershed. They're very, very, very hippy-dippy, no herbicides ever in a million years. And then they got Japanese knotweed. And then they had to really work with the community, and they got buy-in, and they were able to start treating it. But what they ended up doing, and they hardly used anything. I think last year, they're on their 10th year of treating it, and last year they used just a little capful of Polaris, but they sponge it. So they take the sponge, they sponge the leaves, and then they cut the stems, because it's kind of grows. You can't really see this, but it kind of grows like bamboo. So they cut the stems and they do stem injections. They put cardboard down on the substrate below it just to catch anything that would be dripping. So that's how they've been doing it for 10 years, and they're almost at eradication. They're like super, super duper close. And what we have in San Geronimo Valley right now is possible to be eradicated. It's not going to be like a keeping it at bay thing. We're able to get a hold of it and do eradication, but it's mostly on private property. So I just have to get everyone to agree to let me map it and then agree to treat it. And that's going to be a hard one, because I've always just used, manual labor and people and having fun, and that one you can't do that. And a lot of people are like, call me when you get the group together to go out and remove it. And I'm like, no, we're not doing that. And I put on a workshop, and like 4 people showed up, and I did more outreach than like anything. And it was in the newspaper and everything. And like, nobody showed up. I'm like, you're really going to care when you can't sell your property because of it.
Is this something you find in the nursery, or is it in basic?
I believe.
How does it get around?
Right, it was an ornamental. It was in the nursery to begin with, and I mean also they use them along railroad tracks for erosion control. But it's like if you don't have a green thumb and you like kill every plant like my boyfriend does, you can make this plant live. Like you just look at it and it's like, oh, it just grows, and it's deciduous, so it drops its leaves. So in the wintertime you can't find it. So I've had like people from Fox News or something here or down here in the Bay want to come up and film it in the wintertime, and I'm like, you guys, like it's not here, it's fallen leaves. Like you're just gonna be like recording me talking at the side of a creek and nobody's gonna get it.
And is it going to new locations because of through seed?
Oh no, so it spreads, thanks for saying that, it spreads vegetatively. And so it wants to be broken. It's not really stable.
Yeah.
So it's riparian, so high waters come up.
It floats away and receives.
Yep. Yeah, it'll scour out little bits and pieces, whatever floodplain or side point bar it lands on, bam, there it is.
So
it
that's
keeps
what Wineries has been doing vegetation removal with it.
Yeah, they've been, and I told them, I was like, well, I don't know about herbicide, and they're like, all right, Sarah, like that's cool. You find us case studies where non-herbicides worked, and we'll try it. I had no luck. But that's how I found Mental Restoration Council, that it was their issue. I'm good friends with them, but I had no idea they were dealing with it, and thankfully they came down and gave a presentation for the 4 residents that did show up.
And so in Japan, what does it do?
I imagine there's some kind of like predator, something eats it, something of the sort keeps it in control. We just have nothing here that controls it. There's nothing that wants it. And that's the big thing about invasive species, I'm sure you guys hit on with Calypsi, is when you have a non-native invasive species, it didn't evolve here. So our wildlife, our native flora didn't evolve to it too. So it's kind of like, what is this? How am I going to use it? What's going on? So it just doesn't provide any benefits.
Do they have it in the East Bay Regional Park District system?
I
Do you
wondered
know?
that too.
I've seen on a map.
I think
I've seen it in the East Bay. I'm not sure where, but I've seen points of it in the East Bay. So we have a little bit in West Marin. There's a little bit in the East Bay. Sorry to tell you guys.
No.
Washington, Pacific Northwest, and then Humboldt.
Good test question. Where would you look for more information? Quick.
Calypsi.
Calypsi, right? Where else would you look for distribution?
Calflora.
Weed Mapper, Calflora. Boom, there it is. Jump in there, figure it out. This is brand new news to me.
It's awful. Yeah, I've only been doing restoration for like 8 years, but I've never heard that plant.
How long has it been in Marin?
It was first noted by State Coastal Conservancy in 2010.
Oh, no.
Yeah.
Oh, wow.
Yeah, and it is spreading fast. And so Marin Municipal Water District, I go out and we do a lot of surveying and monitoring for salmonids. So they're in a lot of backyards, and they've been noticing it and mapping it. But you can't, you can't really, a lot of homeowners are like, where is it? And you can't really be like, oh, we have a map of it, and like, here's where it is, because, well, one, the map has to constantly be updated, because every time it gets ripped, it reestablishes somewhere else. But another one is, the last thing we want are private property owners thinking that we're like collecting private information on their property when they give us access, because like I said, it's already a really contentious area, and it's like walking on eggshells in San Geronimo Valley. So you just want to keep really good relations. And if they all of a sudden were like, oh, if you're mapping stuff and taking photos of my property, it has nothing to do with fish, you're no longer allowed access. And then we don't have the information we need to try to get to our recovery target numbers for endangered salmonids. So it's a really delicate balance, a really interesting dance that we have to do. So values of riparian corridors. So native vegetation, we already talked a little bit about this as far as the benefits of native flora and native fauna evolving together. So notice here, this is a photo, this is of Alima Creek, and I really love this shot because well, there's only one thing I don't like about it, and it's kind of like a bowling alley. It's a little straight. I'd like to see it a little more sinuous. But I love the fact that it's not incised. You can get to your bank full discharge, so that's when your water levels, your water surface elevation reaches to the top of the bank in a 2-year interval. That's going to happen here. It also has the ability to activate the floodplain, which has a lot of different benefits in being able to knock out. So think about like when the water's coming down and things are starting to flatten out like this, and the waters can lift up and go out to the floodplain, it slows down. And when the water slows down, it drops up the sediment. So then you have all these nice fines that go over here and actually provide great substrate for vegetation that'll then lock it and hold it in place and keep it from going back into the stream. So it's a win-win. I love seeing images like that, minus the fact it's a little too straight. So native vegetation, food, we have twinberry, we have native blackberry, we've got nectar from the flowering plants and trees, there's hazelnuts, there's acorns, so no shortage of food there, and a lot is being done now with Point Blue Conservation Science. That's a resource if you guys haven't written that one down yet or know of it, Point Blue Conservation Science. So they've got a really cool tool. It's like their Climate Smart Toolkit. It's an Excel sheet, and you can really work with trying to make sure that there's a food supply for our wildlife all year long, and really thinking about, going into the grocery store and having a ton of food instead of it being, the bare shelves, depending on what you ended up planting. So if you're focusing just on like your 2 favorite species, that's great for you. It's not great for the wildlife. You really want to have a nice mixed bag. You really want to think about the timing that things are fruiting. And back in the day, we used to really focus on, and I can't even say back in the day, it's still current for National Park Service, of using genetics from plants within the watershed and not bouncing out of watersheds. I understand that. That's great. With climate change, it's not a bad idea to start mixing up the genetics and being able to think more about, all right, so it's a native species, but it's more acclimated to a drier environment. So maybe bring those genetics in and think about it, and making sure that we're, doing restoration with an eye to climate change and changing temperatures and changing environment. So shelter, obviously shelter is, very key. It makes me think of, well, I guess we'll talk about canopy cover in a little bit. So nesting habitat, migration. Riparian corridors are actually migratory corridors too. It's a safe place for them, if you don't have a ton of culverts. It's a safe place for animals to be able to go up and downstream. They can find food, they can find shelter, they can find shade. So it's just, a nice migratory passage for them. Biodiversity hotspots. I should write a note and send you guys a paper. There's a really cool paper on all the benefits, all the benefits around the biodiversity of a riparian system. It's just like, it's so alive and so much is going on. It's hard for me to even wrap my mind around. But canopy cover. So canopy cover is when you have this overhanging vegetation, right, that's going over the stream. And this is one of the reasons I do love this, other than the floodplain being able to be activated, is all these trees. I only see a few areas where the sun's really hitting the water. But when you have this canopy cover, you are shading the water, which cools the temperatures, right? So a lot of aquatic organisms actually have temperature thresholds that become lethal. So remember how we talked about TMDLs earlier, total maximum daily load? You can have a TMDL for temperature. So you really have to start working on your temperature and understanding the lethal counts around that. I know for salmonids, for coho, they're a lot more sensitive, and it gets around like 53 degree Fahrenheit, and like 12 to 14 Celsius. So you want to keep your water temperatures cool. Another advantage of keeping your water temperatures cool is your DO, your dissolved oxygen levels, are typically higher in the cooler waters. When you have this roughness and this vegetation along the edge, you usually have some mixing going on. So you're also getting an oxygen input through the mixing. So you're having more oxygen in there available to them too. The roughness is also allowing the complexity and geomorphic shaping. We have nutrient cycling going on. So as the tree leaves are falling off, deciduous wintertime happens, you have nutrient cycling with the leaf litter input. You also have bugs falling in there, which is really great for the fish. Let's see. The complexity with scouring and deposition. So depending on what vegetation is down there, so like alder trees, you'll see a lot of times they're right up on the bank. They're like hugging it. And the water, the roots are really cool. They're like red, really, really pretty. I should have put a photo of this, because anytime I'm in the field, I'm like, ooh, pretty alder roots. So anyway, those create these really nice little back pocket, these little areas where fish can hang out and escape high flows. and also hide out from predators as well. Get out of the sun, hang out in the shade, provides that cover that they need. I think that's good. Do you guys have any questions on this slide? Because I could talk about this for a long time. I love riparian.
When you were mentioning increasing the biodiversity of the native plants because they can adapt more to climate change, how far away from the riparian area do you look for other seeds to introduce? Because in a lot of restorations you want plants from that particular area.
Right.
With the restoration, you don't want to grow plants in soil and bring in new soil.
Right.
So I'm just wondering what your...
So you're not taking plants that aren't riparian and putting there. You're not taking like an upland species and putting it in the riparian area. You would take a riparian species from a different watershed.
Okay, because I thought you said plants that could grow better in drier environments.
So riparian, but in a drier watershed.
Oh, okay.
Right. Sorry.
Okay.
Thanks for clarifying that. Yeah, I'm not
Yeah.
gonna. What would be a good example? I'm not gonna put Baccharis like right there on the edge of the water because they're not gonna like that. They wouldn't survive anyway, right?
No.
So there's some species that are just really xeric and they're not gonna make it. But if you
Okay.
take a riparian species from riparian species from a different watershed and pop there. But it's a good point as far as soil. So if you're collecting seed from a different watershed and rearing them in your own nursery, then you can still have your native soil, or you can have a soilless mix. So it just depends. Restoration is so up to the restorationist. You'll hear, like I talked and started with the definition of restoration. We all have different definitions. We all have different practices. It all depends on your experience. It depends on your watershed. It also depends on who you work for. If you work for National Park Service, I have a nursery with them, and they're really, really strict. Like, seeds can only come from the Logging Creek watershed. Plants can only be planted. Like, I'll collect the seed, we'll propagate the seed, and those plants can only stay in the Logging Creek watershed. So as much as I want to help my buddies over in Fairfax, I can't give them those plants. They're free. I'm growing them for free for homeowners to do restoration, but they have to stay in Logging Creek watershed. So it just depends on so many different things.
Do you
that have nothing
heat
to
up
do
the
with nature.
soil? Do you heat up the soil to kill Phytophthora?
We don't.
You don't heat it up?
No, we have a lot of other BMPs, but that was the one that we just couldn't do. Like, we
Okay.
follow all the other rules with
Yeah.
Phytophthora prevention, but that was one that I could not get the Chief Resources Manager, Gordon White, with the Point Reyes Seashore.
Mm-hmm. Just
So
expensive.
expensive.
Yeah.
It's pasteurizing the soil.
So,
Mm-hmm.
yeah, like solarization.
Mm-hmm.
Yeah. So, and that takes a long time. You got to be able to spread it out and tarp it. What were we going to say, what?
I was gonna say, also adding on, just winding 2 quick points. One is one approach, and I know every agency is different. One approach to thinking about where to select material from is think about where it would naturally go. So if it's a wind-blown species and you're near a ridge top, to me, whether it's in watershed A or watershed B, depends on where the wind blows. If you're looking at berry, let's say, is dispersed after it passes through the gut of a bird, to me, I think of a much larger radius. So those are some of the choices, but yeah, Sarah's absolutely right. Sometimes you're confined, and we've actually had people, we had a project we were working on, they said we actually can't use these fantastic plants and these seeds. Sorry, go get your own. Go spend a bunch of years collecting. Another quick thing I was just going to say is, if you think back to Tom in the first lecture where he was talking about the connected, the Conservation Lands Network, the CLN, a lot of these riparian corridors are the only way those different preserve foci are connected, and so they're absolutely vital because there is so much strong protection around these. So in terms of being a corridor, sometimes this is where you're going to see your big cats. This is where you're going to see a lot of really interesting migration. So I just wanted to underscore that.
Yeah, it's really, when I first learned that, I was like, it's just one of those things that you don't think about, and then when someone says it, you're like, that makes complete sense, of course, there's like nice covers and shrubs, for the most part, other than parts of Marin, there's not someone living like right on the edge of the bank. So yeah, it just gives them that space and ability to traverse. So, as far as in-stream habitat restoration, I do a little bit of work here. So this is, as I was talking about, that cover with the overhanging roots. So you can't really tell, but this is a ledge. And so this is a great place, again, to escape from predators, and hopefully there's a little bit of, some roots coming down here into the water where fish and other aquatic organisms like the federally listed endangered California freshwater shrimp They love to live in the roots. They'll like, hold on for dear life, actually. So these kind of areas, I always try to get residents to really prioritize maintaining them and making sure they're looking good and not getting rid of it, because a lot of people will be like, oh, I'm going to take this tree out because it's going to fall in anytime. I'm like, please don't. Just let it. And then when it falls, like let it fall on its own and leave it. We have a massive history of cleaning out our creeks, because we don't like them messy. We want them to be tidy. We want to clean them out. And so a lot of people historically cleaned out our messy creeks. They took out all the wood. They wanted flows to go. And that's another thing for flood control, which is a lot of my job is really negotiating with flood control district and Marin County when they want to go out and tell private property owners how to manage their streamside property for flooding. I'm like, can we mix this up a little bit and do habitat or ecological integrity, habitat, resilience, and flow conveyance? So now we tag team it, and so whenever they go out and teach people, I'll go out with them, and so they'll talk about, don't have anything in the stream that's going to plug your culvert and create backwatering and flooding. And then I'm like, but don't go removing all your overhanging veg. If the water is not going to touch it, don't take that limb out. So I do understand that they can't leave wood in the stream. I really wish they could, because there are steelhead in Corte Madera Creek. But for the most part, you can't, because people built in the valley and they flood otherwise. So there's, again, this delicate balance of flood control, flow conveyance, but habitat integrity, ecological functioning. So I focus a lot of my time in Marin trying to put wood back in the creeks. And you wouldn't believe how expensive it is. It is so expensive. And to be able to do that, well, I'll talk about some projects later. But either way, it's really expensive. It's ridiculous. If you guys are ever in a situation where a tree has fallen into the creek, if it's not going to totally destroy a property or cause flooding, just leave it. Everything's going to be happy. It's also a nutrient input. So as it's breaking down, you have your oh my gosh, I can't even think of the word, your raspers and your grazers, your benthic aquatic organisms, your benthic macroinvertebrate organisms, and then other aquatic organisms will come in and clean off the algae and help break down the wood. So it's a really great piece for that as well. Large woody debris, why I've spent a lot of time working around it with endangered salmonids, is it's great habitat. So when we talk about scouring, so that process of erosion, so on the downstream side of a wood installation, large wood installation, it's going to scour. And so that creates a nice deep pool in the summertime when the fish are like, oh my gosh, where am I going to go? It's really, really hot. They can go hang out in those deep, cool pools, and it's their summertime refugia. As well, in the wintertime, it's winter refugia. So when you have those high flows coming, they can hang out in the little eddy behind the wood and just kind of get a little respite right there, kicking it. As well, cover, hide again, from the predators, being able to hang out underneath, and take advantage of any of the aquatic organisms that are breaking down the wood and eating the algae off of them. Root wads, same thing, they're just more complex. So sometimes, if I can, working in Marin, if someone's having a vertical bank and they're having a lot of erosion and their bank is failing, they're like, I want to put in a cement retaining wall, which again speeds up the water hits it, it goes that much faster. You can't plant cement, so you're losing your canopy cover, your riparian vegetation. But I'll talk them into installing root wads to deflect the flow. So here comes so you get this nice gnarly root wad, flows come, hit it, and instead of hitting the bank, it hits that and can kind of ping pong back over this side. Of course, with private properties and everyone really close, you have to really think, okay, when that ping pongs or like a pinball moves, where is that water going to go? Because you deflected all that energy elsewhere. So ideally you have a floodplain for that to go and not someone's property where it's going to flood or start eroding their bank is really a big one.
So this is a dumb question. Is a root wad a living root, or is it a dead root that you've got, or is it just called a root wad that looks like roots?
No such thing as a dumb question. I love asking.
I was going to ask that too.
I love
I've never heard of
asking.
it.
I love asking questions.
Spit wad, yes.
So it
Spit
depends.
wad, no.
It depends. Sometimes, like bay laurel trees, they'll fall over and the roots will kind of rip up, but there's still enough that it'll stay alive. But with restoration projects, typically you're buying a root wad that's from like a forest, from a timber company or something of the sort, so it's dead, and you anchor it down. So we'll talk about nuts and bolts of practices with that, but typically they're dead. But in a natural system, passive large wood recruitment, fall down depending on the species, it'll still stay alive.
And how long will it last?
Depends on the species. So we focus on conifers. So redwoods are like cream of the crop. I have a really hard time with buying redwoods for restoration projects because you're you're taking them from somewhere. Okay, great, you're making this habitat better, but where did that come from? Did you just denude another landscape just so you can save the fish over here? I mean, don't get me wrong, I want to save the fish, but everything that comes along with logging, I don't really like that. I don't sleep well at night thinking about that. So there's a lot in the way of now new up and coming projects where they're using eucalyptus trees, and I've been pushing for that. I'm like, whoa, we got so many eucalyptus trees, they're non-native, they're invasive, like use them.
And they're big.
And they're big. And they're endless, and we need to get rid of them.
They don't leach too much chemical in the water?
What do you call it? You cure them for a year. So you pressure wash the crud out of them, all those root wads, pressure wash, and then let it dry out for a year. I have heard restorationists that have gotten away with less than a year. Better safe than sorry. Because a project that we're going to talk about with National Park Service, they learned that lesson the hard way. And it wasn't dead all the way, and now they have a living eucalyptus tree that they planted in there for large wood. Whoops. But that's what restoration is. Learning lessons.
What about
Apply it next time.
all those trees that died in the drought in the last couple of years that are throughout all their forests? Can the timber companies use the root wads and sell them and get some money that
This
way?
winter, I have been drooling at the side of the road everywhere I go because
All
they're
those dead
clearing.
trees.
Yeah, I'm just like, oh, what's the DBH on that one? Like, look, I wonder what kind of species that is. And then I'm like, how much would that cost? Because I go up to the Sierra Nevadas a lot, and they've had a lot, especially with the bark beetle outbreak too after drought. And so I'm just like, how much would it cost to get those loaded up on a truck, which is usually the most expensive part, is trucking them. So yes, you can. And if I had a place to put the wood, because I had that very thought, I was like, I'm going to reach out to all the people I know, like Tahoe National Forest, El Dorado National Forest, like people down in Marin and all the different municipalities that are dealing with a lot of the landslides that are happening. Give me your trees. But we have...
Well, just the roots is what you want, right?
Well,
you want the limbs for the streams, too.
Well, I like the trunks, and I like the root wads, both.
Okay.
And so either or, I mean, both. I'm just like, that's really exciting. Because if you write a grant and you're having to buy it, they're really expensive. They're like almost $1,000 a piece.
Yeah.
So depending on where you're getting them. And so when I see that, I'm just like, cha-ching, it's match. When you think about writing a grant and you need to like show a funder like, hey, I'm willing to pitch in some money. If you give me some money, I'll give you some money. So if you have your own logs and your own root wads that you scored off the side of the road or from some other project, then you can put a value on it, what it traditionally is, and then that's you showing the funder, hey, I'm putting in this much money, give me your money, and like bada bing, bada boom, let's shake hands.
What about mitigation? People doing mitigation with giving those roots for free.
Yeah.
In exchange for mitigation credits.
I don't know how it works with mitigation credits and mitigation banks. I'm still trying to understand that because I get asked that question a lot because people, I find projects for project applicants that need to do mitigation, but usually they want something that's like shovel ready, and I'm like, permitting is not, you're not getting this done tomorrow. It's gonna take some time, and I want them to pay for the permitting. I'll help them with it, but so I don't know how that would work. But if they were willing to use the wood that they scored from a development project, say they had to remove some trees, that they're willing to use those trees to install in that local watershed, that would be great mitigation. But as far as just passing off the wood and it serving as mitigation points, I'm not sure how that works.
I think that'd be typical for the agencies to agree with that. Mitigation banks, typically you're trading acre for acre, so you're impacting either temporarily or permanently critter habitat. Because that's what most mitigation banks are: frogs, salamanders, and such. And so I think you would probably be viewed as a positive influence if you could offer them some free logs, but I don't think they'd give you the acre credit, because that's what those banks end up caring about. You impacted 0.25 acres of wetlands. You're at a 3-to-1. You need to buy 0.75 over there.
Okay.
So.
Yeah, and if you're like culverting a stream, then it's like 1-to-1. So like one project in Novato in northern Marin, they were going to be putting the creek in a culvert for 860 linear feet. And when I talked to the regional board, I was like, hey, I got like some projects, like I can do like a fish passage over here and it could be in the same watershed. And the regional board was like, no, we want like with like, if they're going to be culverting 860 linear feet, we want a creek daylit for 860 feet, which I got really excited. I was like, hot dog, let me find 860 feet of like daylighting a creek. I would love to manage a project daylighting a creek. That would be like awesome, so dreamy.
Yeah.
couldn't find anything because they also wanted shovel ready, and I'm like, daylighting a creek shovel ready? No, no, this is gonna take some time. So that's the only disadvantage of people that come to me wanting mitigation projects, because they want it now, because they're already in that process of trying to negotiate and get their permits. So they're ready to, like, they need to tell the regional board right away, or Army Corps, like, oh, I've got this set up. Otherwise they can't move forward, and so then they jump ship, and I'm like, but I really want to daylight 860 linear feet. Let's do this together. So another aspect of in-stream habitat that I work on is fish passage. So we talked a little bit about San Clemente Dam and that, or on the Carmel River, and that dam being removed. What do you guys see about this bridge right here? Because you don't really think about bridges, right? You know, you're just like, oh, a bridge goes over water, that's great. You don't really think about what kind of impacts a bridge can have on a waterway. But what is I don't know, what do you guys think about that? Anything stick out to you other than it being kind of seemingly a scary bridge?
Is there any sound that transfers down that's a problem, or runoff from the road?
Runoff from the roads, oh man, we could have a whole conversation on stormwater runoff and pollutant and water quality. But
that's a big thing, the runoff from the road.
Yeah, that's a really big one in Puget Sound as well. Yeah. So, but no. So think on infrastructure.
Is there
Construction.
erosion on the side that might cause it to collapse at some point in time?
That's a good
Because
point.
it's- Because there are all those rocks.
Right. Imagine if the footings, so those are the footings, imagine if those footings were in the water. And you have water moving around it and hitting it, right? So this is what we call a channel spanning bridge. And this is what the agencies want to see. If you're going to be doing any kind of bridge projects, they want a channel spanning bridge. They don't want any footings in the creek, because when you do, you start having these constriction points. So if you can think about like a fire hose, or the Novato Narrows, if you ever go on the 101 North, I always think about bridges and constriction points in hydrology when I'm in the Novato Narrows. But it winds down to just a couple of lanes. Traffic backs up, so it's like water starts backing up, and then on the other side, as soon as it frees up, everyone's like pew, pew. So it's like a fire hose, right? The water's just like it's open up, and it creates more vertical erosion, aka incision. So you get a lot of different issues around that, but also it impedes with different kind of geomorphic processes, which also is a big issue around culverts. And I don't have a picture of a really nasty culvert, but I'm sure you guys have all seen them, where you're like, what's going on here? And you see a culvert, they call it shotgun style, where it's just sticking out, and there's no energy dissipator like a rock or something below, and it's just blasting and creating kind of like a plunge pool, more of that itty bitty fine sediment going into the creek. So it causes a lot of erosion. If you can have your culverts that are actually on grade and bottomless and arch, so this is also, we're talking about new sexy terminology in restoration today. So we got our channel spanning bridges, and we have our bottomless arch culverts. So this allows, well, I'm not even gonna say, what do you guys think? Why do you think that I get excited about this kind of stuff?
Well,
Okay,
a lot of water can
That's
percolate down
Yes,
into the
yes,
soil.
Well, fish access,
yeah, that's another one.
it's,
All kinds of benefits, right?
yeah.
Yay! So we still have passage. We have a natural bottom. So also the natural bottom is roughness. So we have this roughness going on, so it slows down the water. If you have a straight-on culvert, cement, or corrugated metal, or metal in general, it speeds up the water. So it becomes a velocity barrier, which also, again, when you have that water that's speeding up, you have more chances for downstream erosion. So you have your roughness, and it allows sediment to pass, so that bed load can still move around. We can still have our natural geomorphic processes of, we have the scouring, we got the erosion, we have the sediment mobility, bed load transport, floodplain engagement. Oh, so I should have talked about this with floodplains. Have you guys heard of Jacob Katz with Cal Trout with floodplain fatties? Have you guys heard about floodplain fatties? Oh man.
No.
So, when floodplains are activated, and you're in this is actually going on, there's a lot of experiments going on in the Central Valley right now in the rice fields, and working with farmers to allow Chinook salmon to be reared there, just to see what happens if you actually let salmonids kick it on the floodplain. What does that mean? They get huge. When you see the fish density and lengths of salmonids in stream versus those that are reared, so they're juvenile, they're par and juvenile, they're in fry stages, so they're young before they out migrate. They get to hang out in the floodplains. They get massive, and they get ready to actually survive the ocean.
Because of food?
Yeah, a lot of food, slower moving water. They're expanding less energy. They're just like, they don't have to metabolize a whole lot just to hang out and eat and eat and eat.
So all the fatties.
Yeah. Floodplain fatties. And so with nice diverse riparian vegetation, they can still be able to escape predators. They can still get the cooler waters. And there's actually a study that I just recently was hearing about it at the Salmon Restoration Federation conference, because you think, oh, floodplains and maybe it's getting hot. You have more shallow water, so it heats up better. Well, they had an experiment showing like the nice hyperureic flow exchange. So your hyperureic is your flow of water that's subsurface. There's a nice exchange. It's a lot colder because it's not exposed to the sun. So there's a nice exchange going on right there within these floodplains. So it stays at a non-lethal temperature. They can hide out in like different vegetation, and then they just like fatten up, and then they go out to the ocean and they have a higher ocean survivorship. So these are another reason why I love my floodplains.
Are you talking about the Delta rice fields?
Yes.
Okay.
Yeah, the Yellow Bypass area, right there with Peter Moyle and Jacob Katz.
Yeah.
Yeah, so they've been doing, they present on it a lot. It's so fascinating. If you just type in floodplain fatties,
Okay.
different presentations will come up, different papers that have been, and I mean, it's such a hot topic. Like people just keep doing more studies and more master's thesis around it, looking at all these different parameters around why is it so great, and they're still doing the experiments, and now they're trying to like spread it. So they're like, okay, like let's do this experiment like in other areas. So they're looking at different places of California, like where can we utilize and work with farmers and ranchers and like really utilize these floodplains to get some fat fish. So Laguna de Santa Rosa and Sonoma County.
Some water from the Sacramento into them?
Is that what?
Is that just diverting some water from the Sacramento?
They breached a levee to be able to do it. Yeah. And so when the rice fields flood, instead of draining them, they've been able to alter the water exchange however it's going to where they leave the water there longer instead of just draining it. And then the fish tend to know, or native fish just know when the water starts going and going back into the main channel. There's really little evidence of stranding. However, the non-native fish don't get the cue, and they end up being stranded.
Oh, wow.
Raccoon snacks.
Darn, yeah.
And when
Wow,
you're using the
that's
term
so good.
floodplain, I'm sorry, I probably missed this earlier on. That's a floodplain that's active and has a creek running through it, not necessarily like a bench.
Well, no, I didn't necessarily go over that. So that's a good question. There's like inset floodplains, there's your benching and your terracing. I'm thinking of your point bars and anything that is at a low enough elevation to where when you get that 2 year, when you get your bankful discharge, that it's actually going to connect and go out onto the floodplain. But
So in this rice paddy area, because they've breached some levees, you're considering that like a floodplain then?
well, it all was floodplains, right? That's
Yeah.
why they put the levees there.
Yeah.
So yeah, it's just utilizing the existing floodplain, but they're
Yeah.
manipulating the timing with having the water go off and having it stay there longer and rearing the Chinook salmon. And they're all, I'm pretty sure they're all hatchery Chinook. I'm not sure from which conservation
The hatcheries
hatchery.
just went upstream about 8 miles.
Okay, then there's probably those Chinook hatcheries, or those Chinook from that hatchery. There are so many hatcheries. I can't keep up with them. Thank goodness. I don't have to work with hatcheries too often.
Well, the hatchery by the Folsom Dam, they put it because they knocked out, I think, 8 or 9 miles of salmon habitat. So the fish goes right out there. They come out, it's like
Yeah.
everybody eats them.
That's another thing is planning. Remember we were talking about planning? Plan for these things. Think of worst case scenarios and how that shakes out, and actually like observe what you did and pay attention, and then adapt it and change it as you're going with it. Because for me, restoration's been really fluid and just learning. You do something, you do your pilot projects. Don't do it too large. Do a pilot first and see what response you're getting. Make sure you have asked the questions, you've done your planning, and then you implement, and then you want to monitor and assess, and then you want to reevaluate and change it if you need.
I have a question about those culverts.
Yeah.
I live in Oakland, and a lot of people want their culverts removed in the flats of Oakland so that they're not just having streams in the hillside area, but having the streams go from the top of the hill down to the bay there. And if you put a bottom, if they are doing road construction and they replace a culvert with a bottomless one, would that cause the street to cave in later on, or would there be some danger in doing it that way? Because they're tearing up a lot of roads down there right now because of construction.
Mm-hmm.
And I don't know, how they're replacing the culverts when they're doing all this.
Yeah, I'm not an engineer, but that's a great thing about engineers is they're going to do the hydraulic calculations, they're going to do the monitoring, they're going to do the modeling, and they're going to be looking at what does it mean with your area of land that's draining, so your watershed. So they're going to pay attention to what is your potential, your runoff coefficient, and then you're gonna look at your cubic feet per second, your CFS, and pay attention to different, and a lot of times you have to construct, for you to get a permit, at least from Marin County, your culverts need to be sized for the 100-year flow event.
Oh, okay.
So they oversize them now because of, they're like, oh, it's really expensive ripping up a road and having to replace a culvert, and culverts have a lifespan. Different materials have different lifespans, and so with having to rip it up and how expensive it is, they're like 100-year flow conveyance, which of course different agencies will argue on, like, do you have to be a stickler about that? Because some streams are like, this isn't going to be an issue. Like, we don't need a 100-year flow. But right now, as it stands with Marin County and their Department of Public Works, it must pass a 100-year flood. They don't have any exceptions around that. Oh, before I do that, what is one thing that keeps sediment from transporting and building complexity and feeding the alluvial fans and deltas?
Dams, yeah.
Yeah. Okay. So I am not a techie person. Full confession. I don't know how to embed a video. I feel like I've done that before. I tried doing the copy paste of the embedding, and then I just put the link, but it's a really cool video, and you guys should see it.
You want me to try and get it going?
Yeah.
Let me see if I can make this go.
So where's this one located?
So this is in Washington.
The state of Washington?
The state of Washington. When I
Is
went
there a
up there,
documentary on this?
is there what?
Is there a documentary on this?
Oh
There
yeah.
is,
Yeah.
I've
It's,
seen
oh my
the
gosh, there's so
documentary.
many different, is that one Damnation?
Yeah,
Yeah.
that is.
Yeah, that one's, it's really touching. Did
Sarah,
you
what
cry?
slide
I cried.
number are you? 12.
Which what?
12. I got you.
Okay.
It's like,
Yeah.
Yeah, once they remove it, they've just been like letting it do its own thing. So,
Yeah.
of course, with dam removal, you have to be really careful, obviously, about what's downstream. Oroville taught us that one. They didn't really
Yeah.
plan that one out accordingly. And of course, that wasn't a dam removal, but
Give me a sec
With-
here, guys. This is
what-
pretty cool.
It's on my
What
goodness.
river was this one on?
the is it the Columbia River?
Yeah,
That sounds right. It's in
they
Washington.
did it for the salmon, right?
Mhm.
Yeah.
And yeah, so this is actually the nation's biggest restoration project.
Mm-hmm.
But when we remove those 4 dams on the Klamath,
yes,
that will
that's
then
right.
be
Yeah.
the biggest
Yeah.
restoration
Mhm.
in history internationally, I believe, actually. Which is
Mhm.
pretty cool. So Elwha Dam, it was 108 feet, 33 meters high, located in the state of Washington on the Elwha River. Okay. It's 4.9 miles upstream from the mouth of the river on the Strait of the Juan de Fuca. The Elwha River Ecosystem and Fisheries Restoration Act of 1992 is what authorized the U.S. federal government to acquire the Elwha Dam and the Glines Canyon Dam hydroelectric power projects for decommissioning and demolition for habitat restoration. Removal of the Elwha Dam began in September 2011 and was fully completed by March 2012, allowing the Elwha River to flow freely through the site. And this is the largest dam removal in U.S. history.
That's awesome.
You guys ready?
It's pretty exciting.
Dams have a lifespan. It's like nibbling it.
Mm-hmm. Yeah, and I've looked at the comments of some different construction contractors, and they're like, "Oh my gosh, are you kidding? This guy was nuts for doing that." You know,
It's dangerous?
Oh, so dangerous.
Yeah.
Like all of it, he's really counting on all the rebar that's set in there.
Look at all the water coming off the right side.
Oh my God,
So
you could
those
be
are
swept
spillways,
away.
Yeah.
Yeah.
Oh, that does look
right there
dangerous.
was
Right?
dangerous.
So yeah, all it takes is like if some of that rebar had rusted out, a
Oh.
little nick, he would have gone off the edge.
Oh my God, that is scary.
Yeah, I'll pass on that job.
Yeah.
I wonder what he got paid. He probably got paid
Hey,
big.
I'm just,
I know,
I
I
just
know.
Yeah, he's
ready
probably
to
retired.
Yeah, he's retired.
Well, hopefully he had life insurance.
He bought his own island. He was just having Mai Tais all day.
That he made himself too. He made the island.
Right. Yeah, he constructed it with some of these remnant pieces of the concrete, right? So it's interesting to see this because, there's a lot of different dam removal projects where they use dynamite. So with the smaller ones, they'll blow them up, which is exciting. I almost put that video, and then I was like, Elwha is so massive and big. Like, it's really to see. But yeah, it's really thrilling. If you just type in dam removal on YouTube, you can see all kinds, and it's now happening more and more. So
Yeah.
you get lots of choices of dam removal projects and different techniques in which they've done it. But
Yeah.
I get
With-
really excited with dam removal.
With Lagunitas Creek and Kent Lake, do the salmon go up to Kent or do they stop at Kent?
They stop at that dam.
Is there any sort of project that has been looking at? Okay.
It takes that cut off about half of their historic range habitat, and because of that, Marin Municipal Water District has mitigation from a state water resource control board order that was issued to them, and their mitigation is fisheries monitoring and habitat enhancement. So as much as I have my personal feelings and thoughts around irrigation districts and water agencies, the Marin Municipal Water District is freaking awesome, and their aquatic ecologist Eric Etlinger is a genius. I love picking his brain and going out in the field. Anytime I want to go get fishy, he's like, all right, let's go monitoring. So we'll go out and do juvenile salmonid monitoring through electrofishing. We'll do spawner surveys, counting the reds and looking at the reds and identifying species around that. And then there's snorkel surveys, and there's smolt monitoring. So as the fish are getting larger and they're going out migrating to the ocean to have their adult lives and get all big and fat before they come back and lay their eggs, they have a rotary screw trap. So it's a device that's set up in the middle of the stream that captures the fish and holds them in a holding tank. And every day you go out there, get all the fish out, and you measure them, you weigh them. You sometimes, depending on the species and how many we're at, we'll do a fin clip, and the genetics from that are sent down to a lab in Santa Cruz from National Marine Fisheries Services. They're really trying to understand the genetic spread and diversity of salmonids along the coastal watersheds.
Who's doing that?
It's someone with NIPS. It goes to NIPS. I never send it out. Like, I take the fin clips and I put it in a little envelope and write the species and location and date and give it to the water district. And I talk to NIMS all the time, and they're like, oh yeah, the Santa Cruz lab, but I have no idea, like, the who.
Calcovax.
Is who?
I bet you it's Eric Calcovax. He was my grad school roommate.
Cool, what? That would be awesome.
And now he's a prof down there, so.
That would be interesting. Well, Dan Logan, that's in the Santa Rosa office, he's done a lot of genetic testing and fin clipping of the northern coastal watersheds.
Yeah.
But yeah, as far as like Lagunitas Creek, everything goes, because National Park Service too, they monitor Bear Valley Creek and Olima Creek and Redwood Creek and Pine Gulch Creek. So a lot of those that drain into the Venus Lagoon too, and they'll send their fin clips down there too. So that's interesting. What a small world that would be.
Yeah, that'd be
Yeah, it's a big deal.
Do they have a good relationship with the official biking, organizations in Marin, the ones with official members?
Do they have what?
A
Say
good
that again.
relationship with the different biking,
Oh, yeah, the
mountain
Marin
biking
Biking Coalition.
the established ones,
Yeah.
to support the salmon and not put in illegal roads and.
Social trails are hard because everything boils down to, and so much of my job is education. Because so many people are like, oh, I want my own adventure. Choose your own adventure. I'm going to go this path. But it's like, you realize you're causing trampling and potentially wearing on, areas of the landscape where then the understory is not going to be able to grow. You start getting erosion and rills, and then those fine little bitty sediment inputs into the stream. But for the most part, the Marin Bike Coalition, I haven't worked with them personally, but I imagine I haven't heard about any kind of issues between them and the Water District. The Water District actually has done a lot of work on the Cross Marin Trail in different ways to just reduce fine sediment inputs, and a lot of culvert replacements and trail improvements. They're really all about the rolling dips that I was telling you guys about. So the Water District is, they're in really good standing with the private property owners have access to go out and do the monitoring, but they have their own construction crew. And at Kent Reservoir, a lot of the trees that fall into there, they have to remove because it becomes a safety hazard to the dam for them going over. So they have their own free wood, they have their own contractors, and it makes it so cheap for them. I'm really jealous. So I'm always like, can I borrow wood? Can I have wood? We're putting it in Lagunitas Creek watershed anyway.
Lisa, how was the run this year on Lagunitas Creek?
So far it's looking good.
Yeah.
We weren't able to get a lot of data around the spawner surveys because the winter was so gnarly, like lack of visibility. We couldn't even see the reds, and it was a little depressing. So I went out on a spawner survey in December, and saw a lot, and it was really promising looking. So the first ones that we have kind of in November are the Chinook salmon that come in, and then December to mid-January we have the coho salmon that come in, and then in January through February we have steelhead trout. So depending on the time of year, there's a little bit of overlap, but you can kind of determine which species laid that red, created that red. I guess you're not laying the red, but created the red. So we weren't able to see a lot as far as our reds, but the smolt surveys were awesome. We were doing really good. We were having like over 200 smolts a day, which is outstanding. And then our juvenile survey that I was doing electrofishing with them last fall in September and October, and those numbers were really, really good and promising. So, but they're on coho are on a 3-year life cycle. So we have 3 different year classes, and it just all depends on what's going on with that year class. And, you know, you can only control so much in their freshwater systems and make you could just make it Goldilocks style, perfect. But then once we go out to the ocean, it's like, you know, you're kicking the bird out of the nest, and you just really hope that they make it and that they're going to come back. So at that point, you know, you're just like, do more creek cleanup so you don't have all the plastic going out to the ocean, you know, like think about other ways that you can still have a beneficial impact on, you know, ocean survivorship. And making things really nice for them at home in the freshwater system so they can get fat and be able to survive and not get munched on as soon as they go out. But I feel pretty good about the numbers. I was sad about the spawner surveys, but specifically because after being out there in December, I went back in February and all the reds that I had GPS'd were gone because of bedload mobility. Things had moved, and it was really cool because the geomorphic processes of like some pools had filled in, but new pools were created. Some point bars had kind of been washed away, but like some new sediment aggregation had, you know, been occurring in some of the sites. So it's just, it got really complex, and a lot of the large wood that's been put in there just really got to start being put to use and adding more complexity to the stream. So for people that go out in Lagunitas Creek every day, like Eric Etlinger with the Water District, he's like, wow, parts of the stream I can't even recognize anymore. And he's like, and that says something, because I've been doing this for 20 years. And he's like, I feel like I know this watershed like the back of my hand. So that was really cool and promising too. So you guys stay tuned. You can always go on to the Marin Municipal Water District's website. They have their like water blog, and Eric provides little updates of like, here's, you know, the count that we got today, and here's what's going on. And he has he's got a really awesome cynical sense of humor, and sometimes you get to see that in his writing, and it always cracks me up. So it'll probably bring a smile to your face if it's not like, by the way, all the salmon are dead. Okay.
What do you mean by GPS the reds?
Oh, so what's that?
Pin on where the red is.
Yeah, so we'll try to track, because that way when you go back out in the field again, you'll know, has that already been tagged? Because we also put a flag in the tree and write the date and what species if we can identify it. So different species of salmonids have different reds. So like a steelhead is really nice and tidy. It's more tight, it's more circular. Coho, huge and messy. They just make a mess with their caudal fins. It's the female that comes up, and that's how you can also identify a male from a female. When it's spawning season, their caudal fin, their tail fin, is just ragged and torn and shredded because they've just been just constantly trying to dig out their red to deposit their eggs, and then they'll move the material back on top of them. And so they work from downstream going up. And can you guys think about why they would do that? Or sorry, upstream. They start up and they go down because of that very reason. So if they're upstream working, all that sediment that's getting stirred up, they start working down this way. And so it's not going to go in and fill and suffocate their eggs. So it's really, really fascinating. And they tend to lay their reds also right at the interface of a pool, like at the lower end of the pool, but the upper end of a riffle. So when you think about hydrology, you have pools, runs, riffles, and glides. And so when you have your pool, usually your next interface is going to be the riffle, and there's really good hypereic exchange right there, and they know that. So they'll kind of pick these areas where the cool water is coming up. There's also a really good oxygen exchange going on there too. But they also are really smart in the sense that they try to find places that aren't going to end up drying out in the summertime, and then their eggs desiccate. So sometimes you'll look at things and you're like, oh wow, they must have not had a better place to lay their reds. And steelhead come in last, so they can actually interpose and like come and lay their reds on top of another salmonid's reds. They're crazy clever and very adaptive. I mean, they're listed as threatened, but they're not endangered. And I don't know if we're going to see them get on the endangered list because they're pretty clever and they're able to get into like higher reaches of the watershed. Salmonids really want to get in the headwaters where it's a lot cooler and it has better spawning gravels. Remember, if we're down in the valley area, it's more alluvial, it's more sandy. But as you go up, it's more the right size of gravel and spawning cobbles for them to move around. And so they'll get up there, but you know, Chinook get first pick, and then we have the coho, and then the steelhead are like, I can go even higher and further. They're really they're like super fish, and they'll live in the riffles. And so riffles are like the shallow areas where it's a lot of rocks, right? And you just have, you know, it's just really shallow area, and that's where you get a lot of your benthic macroinvertebrates, your fish food. They live underneath the rocks, and so the fish will, they'll totally, the steelhead will live in there. So when you're doing electrofishing, you'll find juvenile steelhead there, but you won't find any other salmon species. But they're just really, really tough. They're pretty amazing, and I have to admit, as cute as a coho is, like steelhead are beautiful. We'll talk about. Oh yeah, what's the time check? I don't have my phone in front of me. I want to make sure that 5:47. Holy cannoli! Let's just blow through this. Okay, so overview of restoration as a process. This was some information from Bruce, so I'm just going to read from it because since I didn't create it. Get to know, so this is really important, that's why I included this from his presentation, is get to know your site and surrounding area and watershed. So again, just planning, you guys. Like, understand your history of your area, figure out what your existing and target hydrologic regime is, understand your flood frequency, timing, and duration and depth, which this gets really tricky when you're in a dam altered situation. I used to do some work below Inglebright Dam on the Yuba River, and the timing is totally different than natural. So you really have to think about that. Understanding your existing and target soil conditions, really think about your drainage, right, and porosity there. Existing and target reference site, your plant community composition, existing and target topography and complexity, and existing and target landscape connectivity. So as Lek was saying, again, with these riparian corridors, the connections, just really thinking about, since one of our big reasons why we're having species decline and habitat loss is habitat fragmentation. So really focus, if you're doing a large scale, because I do smaller scale restoration projects, but if you're doing large scale, really think about how can you keep things connected. Maybe you guys could read this later.
This looks like a Bruce slide.
Yeah, right? I was looking through his stuff and I'm like,
how small can I make the font so people can still read it? Bruce is fantastic. I don't know if you talked about him, but yeah.
Well, I told them that it was probably sad that they got me instead of Bruce, but...
Bruce is fantastic. He runs a firm called Stillwater Sciences, and he is very process oriented. So.
Oh, I met him on a hike.
He writes a lot.
Nice.
Yeah.
Doesn't he write a
Yes, I like
lot?
papers.
Yeah.
For, I
Yeah.
don't know.
Very
And did he do like
For
the
everyone.
nature, the natural history of the Bay Area?
Probably. You'll see Stillwater Sciences everywhere.
Yeah.
Like they're like my favorite consulting firm, and I remember when I first met him, I was like, I didn't know who owned or ran, Stillwater Sciences. I just knew that I'd seen their names on everything, and we'd worked with them in the past when I was in the Yuba River, and then I was like, you're Stillwater Sciences? Like, you are Stillwater? And I'm like, oh my gosh. This is so cool. I love picking his brain. He's such a brilliant, amazing scientist. So, so anyway, restoration should be treated as an uncertainty. Your targets for restoration are often unclear. It's easy to promise this successful recovery, but it's different to actually reproduce the fully functional system, as I was talking about true restoration versus rehabilitation. So this is a big one when you're working with grants, and most of the time you're not doing restoration without a grant because you need the money. But projects are declared successful, usually just to close the books, just so you have the end of a contract period, or maybe as mitigation, and that agency is like, yeah, we just don't want to have to deal with this file anymore, like we're done. Assessment is rarely sufficient to detect long-term effectiveness or to undertake corrective measures. Solutions to restoration problems often involve processes that occur off-site. So again, we all live downstream, right? So think about what's going on in the upland areas, what's going on in the upper watershed. It's all connected. So you might be focusing in on I'm going to fix this, but you could spend tons of money right here if you're not addressing what's actually causing it. So it's kind of like Western medicine. Sorry if that offends anyone, but don't treat a shotgun wound with a Band-Aid. Really think about the different ways that you can address the issue. I guess that's not really applicable, but address the actual issue and not just the symptoms. So really try to figure out how to solve that problem. And so thus Bruce recommends that restoration would be considered within a landscape context. Experiments take the place of trial and error approaches in order to determine restoration measures being effective, and that the understanding of outcomes in early experiments be applied to the later restoration efforts. Therefore, the practice of restoration should build on and incorporate the science of restoration ecology. So examining, which was my favorite class at Sonoma State University, oh my gosh, if you could just take that class. So
Does he teach it?
No, that was Caroline Christian, and she's about to leave and go to Nevada. I love her. I'm not sure who's going to teach that class now, but it's a really fantastic class. So examine important causal linkages underlying wetland degradation and restoration using, I'm not a model person, because again, I said I'm not techie, but I bet a lot of you guys are. So using conceptual models is really helpful for understanding these linkages and helping develop your hypotheses. Again, like I said before, use your pilot experiments to try to understand what's going on, and then you can adapt them accordingly afterward with your lessons learned. And then use restoration to test your hypotheses and advance general scientific understanding. So things that can rearrange a restoration project. I love this slide of Bruce's. I was like, this is so right. Lack or change in the money flow. Maybe you thought you wrote a grant Well, you didn't think. You did write a grant for a certain amount, but the funder decides to only give you half. And you're like, I can't do my project with half the money. Where am I going to get the other half? So it changes the game. Large disturbance after this winter. Oh my goodness, like things have really shifted and moved around. Some people just got projects in at the end of the construction window, and now they're unraveled. Do you guys know the timing for doing construction around riparian systems? Is really good. June 15th to October 15th.
Okay.
That's usually
before the rains and after the rains.
Yep, exactly. You want dry time to be in there, especially if you have like an ephemeral stream where the channel's dry and you don't have to dewater. Agencies, sometimes you have to dewater to do projects. It's really costly, and it has its impacts. So they would rather you find a way to try to stay out of the wetted channel when you can. So June 15th to October 15th, that's when your permits are usually going to say that you can do your creek work. Lack of consideration of all natural processes at all scales. The lack of integration among participants. Woo! We almost had a fish passage project in Marin before I started there, and the grant was secured. All the studies and assessments had been done. Nobody really got the buyout from the landowners. That's a problem. If your landowners aren't on board and it's part of their property, yeah, that's not gonna work out. So collapse of related external ecosystems, ocean fisheries supporting anadromous fish. We talked about that. You can only do so much. For then, I'm gonna skip this. You guys will have it in your notes. What does it take? So restoration projects require thoughtful planning and assessments, design starting the conceptual stage, implementation, post-project monitoring, overall management, which means a variety of stakeholders with a diverse set of expertise, your ecologist, your hydrologist, your engineers, ombudsman or woman, your biologist. What I totally forgot, which I end up calling on a lot, are fluvial geomorphologists to understand what's going on with thinking watershed scale process-based restoration. You need a fluvial geomorphologist. I wish I was. In another lifetime, I'll go back to school and do it.
Wait, what did you just say? Morphologist?
Fluvial geomorphologist.
Alluvial geomorphologist.
Fluvial. F-L-U-V-I-A-L. Fluvial.
Okay.
So it's geomorphology. So it's the understanding of the shaping of the earth with water. So it's like hydrology meets geology in a watershed, and it's super fascinating. They run models like nobody's business, which is probably another reason I haven't been like signing up for school right away, because I'm like, oh, models, techie, it's scary.
And I'll tell you, it's interesting. This branch of restoration in particular is very ecological process oriented. You have numbers coming in from water meters telling you stream height, flow, frequency, all these different parameters. And so it's really interesting when I get to work with riparian restoration folks. They tend to front load with a whole lot of numbers and a whole lot of beautiful diagrams. And then you're just about to get to the end and they're like, so what kind of plant should we put in there?
Yep.
And sometimes it's a little more integrated than that, but it's a very process-based versus a lot of our terrestrial systems that we work on, say oak woodland, grassland. One of the first things we're thinking about is species composition and how to create that. So it's pretty unique in that way that I think this field in particular, this branch of restoration, a lot more calculations, a lot more engineering.
So much.
And it's fantastic. It's much more data heavy in a way that I think a lot of the terrestrial work doesn't seem to shine in the same way, and just has different aspects, different targets. Because for a lot of this, I think a lot of our targets for these are looking at what happened to your banks, how's your flow, what's your creek morphology now, and you're monitoring actual processes, which some people in restoration say that's the ultimate. Plant composition is only a wink in time, but if you get the process right, the function, then you're going to get a lot closer to hopefully creating something that's sustainable.
Exactly. Yeah, it's very process-based, that was well said. And especially when you're dealing with private properties, liabilities, infrastructure, bridges, culverts, you really want to understand those calculations before you touch anything, because the liability and the consequences thereof of a road flooding or culvert getting blown out, who's liable for that? It's a really big issue. So another reason we do restoration is future stewardship. Look at these little guys, they're so cute. Cub Scouts. This is their annual service project of the year, every year. This is Sleepy Hollow in San Anselmo. I usually teach them about water quality. We'll talk about benthic macroinvertebrate bugs, and I bring some bugs that are in vials, and they get to look at them and check them out. We talk about salmonid anatomy, and then I have like a little watershed diorama with some inks and dyes and squirt bottles. We talk about water quality and pollution and how it's all connected to the bay, and they just have a hoot and toot and good time. And then we get out with our bags and go pick up trash and, do a creek cleanup. Site assessments, that's another part of my job, is going out and just doing, working with homeowners one-on-one and checking out what's going on with their property and how to provide them with the techniques that they need to be able to do a better restoration and be a better steward for their watershed. Technical workshops, I put on a lot of hands-on. I'm a hands-on person. Go figure, I ended up in restoration. So I really like to teach people the tools that they need, like hands-on for free workshops that I do like every few months for Marin residents and for anyone. I get people from the Bay Area coming up. I have this one lady from Oakland that comes to like all my things. It's really cute. So they're free, they're hands-on. It's anything from like rainwater harvesting to, I think I talked about that. I won't spoil it. So lecture series, I'll get, kind of like how Lex doing with us, I'll get certain presenters to come and share their knowledge, because there's actually a lot of power in being able to say, I don't know. And it's okay. You can't be a specialist at everything. You just can't. Pick your poison, figure it out, get good at it. Or be like me and just be a generalist. Know a little bit about everything, and it's enough to get you by and understand what's going on. And then tap into your specialist buddies that are experts in the field and rely on them for their information and their contact. Capacity building, 3 E's. I like to do engage the community, and then you educate the community, and then you empower them through that education. So then they're able to actually do something about it. Get their attention first, teach them what they need to know, and then send them on their own so they can actually do it and feel good about it. So teaching techniques, again, so I organize and sometimes co-lead plant propagation classes every month at the Red Barn in Bear Valley, the Bear Valley Visitor Center, Point Reyes National Seashore.
Oh, okay.
That's every month from May through October, and it's 10 a.m. to 12 p.m. And I brought you guys a schedule. I didn't want to pass these out too soon, because I know it gets exciting when you have handouts in front of you and you start looking at them and not paying attention. And they're not stapled because they're all kind of different. Well, the ones that need to be stapled are stapled.
How many, wait.
Just that packet is yours. That's your package.
The whole packet.
That packet is yours.
Oh, I see.
You lost everyone handing those out. It's like,
Okay.
it's like handing out Hershey's Kisses or something. There you go.
Okay.
Did you get one?
That's just for you guys. That's just got the schedule in there. I should have known better.
Yeah.
So here's your schedule. These are the classes. It's on this sheet. So this happens every month. And yeah.
Did you have an extra or no?
I do.
Perfect.
Bam. So that's every month. There's also, I won't give the background story because it's a long story, but there's also a native plant nursery that I started with them. And so again, that's for residents in Lagunitas Creek, growing some plants for the Park Services restoration projects, but also growing plants for salmonid recovery in San Geronimo Valley. I teach soil bioengineering workshops, usually do one every year. Rainwater harvesting workshops, this one is really fun. We set up a tank. We built the overflow for the tank, went into a bioswale, because your tank is going to overflow, right? And then you have a bioswale that guides it into a rain garden. So these residents here are building a rain garden. The benefits around rainwater harvesting, again, you have your groundwater recharge, which is really key. You have stormwater pollutant filtration, so they're really great sponges at cleaning pollutants. And there's a really cool study from National Marine Fisheries Service in Washington State in Puget Sound that did an experiment looking at that. Super successful, amazing. They didn't even plant the rain garden. It was a basic rain garden mix. As well, it's that much less water shooting off, hitting the impermeable surfaces, bringing pollutants into the watershed, and having all that extra volume of water that's ripping and roaring through the channels, causing further incision. Also water quality monitoring. So that was a really fun workshop, teaching BMI. So this is all like taxonomy of benthic macroinvertebrates. So we went out and taught them how to sample for benthic macroinvertebrates, and then also brought them up here so they could actually look at them up close and learn. We also had another teacher that was teaching specifically water quality testing and monitoring and the different kinds of equipment, how you can look at the different parameters like your turbidity, your conductivity, temperature, pH, stuff like that. Soil bioengineering, I heard that maybe some of you guys would be interested in soil bioengineering. So I created this cool little guide. This actually, in real life, it's a laminated pocket size. So you can take it out in the field with you, so you always have your little go-to rules of thumb and you keep it in your back pocket. But these are your basic rules of thumb. And you can do, you can use willow or dogwood. So if it's a more shady environment, willow's like the sun. So dogwoods can go in the shade, willows can go in the sun. There's walls, there's fascines, there's brush layering, brush mattress, and staking. Right up here we have.
Can I get a photo of that?
Oh, of course.
Share these.
Oh, you'll share these.
Yeah.
Oh,
Heck yeah.
Oh, okay, great.
But if you want a photo now because you want to start
no.
nerding out right away,
No,
I
no,
get it.
I want that little pocket.
I totally get it. You want to start staking today, which, by the way, this is not the right time of year. October to February is the right time of year. You want things to go dormant, and you want the ground to be wet.
Okay.
So soil bioengineering, also known as biotechnical bank stabilization. So this is brush matting. So you put some little stakes in the ground. You want your stakes to be 2/3 of the way down. You want to pay attention when you're taking cuttings and pay attention to what's the top and what's the bottom. Your bottom cut at an angle. That way as you get your stack together, because they're dormant, they're not going to have leaves. So you'll be able to know what is your bottom side. Also, the nodes on them point up. Like, so if you see like the little triangles pointing up, then that's your top side, right? So you want them about 2/3 of the way down. And then you get like the little wispies, like your little branches that you just kind of poke in there. You get some burlap twine, and you can just kind of tie them. And you just crisscross them and you create this nice mat. So can you guys guess why this is a good practice right here? Obviously you can see this is an eroding creek bank.
Mm-hmm.
Can you think of why that's a good one?
Once the cuttings sprout, they're gonna reroot into there, and then it also slows down water while it hasn't sprouted yet.
Exactly. It's a nice energy dissipator right there in the meantime, so it protects this exposed substrate as well. Once it starts getting established, the root structure is going to be able to hold all of that in place a lot better and keep the bank from continuing to collapse into the creek. So here's the fascine. So you guys know when you're driving on 101 and you see, or any construction site, you see like the Tootsie Rolls, the wattles.
Yeah.
They're also called a fascine. You can make fascines out of willows or dogwoods. So you take your cuttings like that, you bundle them all together, and here's another one. Oh, you can't see it too good, but here's another one right here.
So you have like a dormer bird?
Yeah, I was gonna say who here's built the fascine.
Yay!
Yeah, we did a workshop. We do this every year. We mix it up with a couple of different species, and sometimes to bulk them up, we'll throw some junk in there too.
Ooh,
like
nice.
bay branches or other material,
Yeah.
coyote brush,
Nice.
to throw in there to bulk it up to make it a little bit larger.
Yeah, it can be a little bit more effective that way too, and just a little bit more roughness that the surface flow can interact with. So you want to do it on contour. It's really all about your surface flow, surface erosion. So you're really slowing down that water before it goes down the bank, and so you're really capturing and dissipating that energy of the water going down, but also putting it at the toe of the bank catches any fine sediment before it goes into the water too. So it'll start grading and building the bank back. So it's a pretty awesome technique. I told these girls to say fascine instead of smile, and it was really cute. That was College of Marin students recently joined me. So here's a willow wall. You typically do your stakes about 2 feet apart from one another for as long as you need. There's also a willow wall. This is a longer one. These guys started in September, so there's still leaves, which is nice. You know, it can be beneficial to have that extra material there, but typically you wait until the leaves have fallen and it's dormant. But do your stakes about every 2 feet apart, and then you take your smaller, more flexible branches and you weave them just like a basket. So you weave and then you push down, and you weave and push down. You want to check in with your local agencies to see if this is acceptable or not without a permit, depending on where you're at in Marin. If you're in Fairfax or San Anselmo, you don't need a permit. They love it if you do this. If you're in unincorporated Marin, you have to get a permit that happens to be about 10 times more expensive than any other permit. It's really obnoxious.
And you cut them, you said in February and March usually?
October through February.
Oh, October.
So like the winter time. So as things go dormant and things are wet. So you want to make sure things are nice and moist when you're planting them so they can focus on root growth instead of shoot growth.
Okay.
That's what that's all about, is using that energy for that.
And is this yellow willow that's you're doing, or?
Any native willow. Arroyo willow, Salix lazylepis, is a really like gangbuster, like shrubby, thick one for erosion control. What time are we at?
Like 6, we should probably
Okay.
wrap up fairly soon. They did permit, so if you want to skip this guy, but you have a
Oh yeah. Okay, so all that I can say about permitting is have a good relationship with your regulators. Like, have a good relationship with them, because it'll save you. You'll get a permit a lot faster, and if they know your intentions and they know that you're doing good things and you're doing restoration, and if you call them, don't call them constantly because that'll aggravate them. Call them as you need them, respect them entirely, and really try to develop a relationship with them, and they will be your best friend and they will help you out. I've had my Army Corps of Engineers give me a permit within a week for a project. So it just depends.
This is a good story to hear. Sarah and I had a phone call about this, especially given the previous conversation and the presentation on permits. So everybody has their own take and everybody has different relationships. Sarah's in a different role than a for-profit consultant. And so it's good to hear this.
Yeah.
And is it easier for people working with NPS or the Parks District to get permits rather than for-profits? Do you find that it's harder?
If you're doing the right thing, nope.
Okay.
It gets a little bit tricky with national parks because you have to go through NEPA, the National Environmental Policy Act, versus CEQA, the California Environmental Quality Act, so it takes a little bit longer. But that's just for the NEPA component, but for getting all your other permits. And actually, if you're doing restoration, you can go through, they have a streamlined process with Department of Fish and Wildlife. Their agency in their 1602, you can go through, what was it, AB, I never can memorize the assembly bill, AB 2193. So they have the 1652 and 1653 permits that you can get, and they're actually required to give you that permit within 30 to 60 days, depending on which one you're getting. So it's a lot faster. Same thing with the regional board. If you're doing restoration, it's small habitat restoration. If it fits within their parameters, you go through a notice of intent, simple form you fill out, you can get your permit within 30 days. So if you're doing good things and you know about the streamlining process, you don't have to wait forever to get your permits. Now, when you're dealing with endangered species, it does take a little bit longer, just for obvious reasons. They want to make sure that you're taking care, all the care possible for endangered species. Emergency projects, like I said, construction windows, June through October. If you have a catastrophic failure in January, you can go through emergency project process. Typically, that's the only time that agencies are going to be okay with you putting rock in there or retaining wall and stuff like that. It's a loophole, and I really don't like the emergency project process because it incentivizes people to wait until a failure so they can then do what they want, which is putting in a bunch of cement or rocks. Agencies are supposed to follow up and make sure that they do a phase 2, more permanent fix, but everybody's busy, everyone's got a lot of workload, so I'm not going to read all of this, but these are just some case studies. So luckily you guys will have these slides that you can look over, but there's a lot of information here. National Park Service, Muir Beach, Redwood Creek, huge restoration project, $13 million. Let's see, these are all the actions that they did. So a lot, but a lot around building new ponds, creating new channels, removing levees, adding bioswales, removing their parking lot, really working on their dune habitat. So it went from pre-project here, pretty basic and simple, to here. So it's got a lot more going on. Here you have your wetland types pre-project over here. A lot more complex over here on your right.
You said this is a Point Reyes, did you say?
This is Muir Beach.
Muir Beach.
Oh,
By
Muir.
the way, if
Oh,
folks
Muir.
get a chance to go out
Okay.
and visit this, they're awesome interpretive panels
Okay.
throughout the site.
And San Francisco Bay Joint Venture has a really cool video, short video that you can pull up and look at. So some quick photos before and after. This is 2011, 2016. Wow, right? Other ones, so this is the same site. This is in 2014, 2015, 2016, 2012, 2013, 15, 16. So from this to that, from that to this.
Fish.
Yee! The fish, that's a whole nother story. They're bringing in they're the genetics from the Redwood Creek coho. They're taking them to the hatchery, rearing them, and then bringing them back. And they just dropped off 103 last winter, and then who knows what happened to them because the winter was massive. And they're probably not that fit because they've been in a hatchery. They haven't been able to really be using a lot of the energy and getting strong.
What was the talk of the science symposium? So I think they have like a video online too.
Yeah, there's a lot. It's a huge project. So from this down to here, you can see the wood rack right here. From this to this. So a lot of great changes. Again, we get from this down to here.
What
Here's the old
company
parking
was
lot.
doing this?
National Park Service. Carolyn Shoulders was
Oh.
the project manager. She's my hero.
wow.
I don't even know. Just imagine how many hairs she pulled out. Department of Public Works, Marin County. This was this is one that just happened. So they added a bunch of weirs in their culvert. They replaced the culvert. Did I don't have the before photo. Oh, okay. So here's really quick. Fish, steelhead trout, coho salmon. Bye. Thanks. Sorry. Here's how you can identify them. Spots on the dorsal fin and this red lateral line. Here's your coho. They have an anal fin that, where's my little arrow? Oh, there it is. Okay, so it's sickle shape. So you can't really see, but it comes out to a really nice point, and they have these big googly eyes. So there's your coho, and there's your steelhead. This is that project Department of Public Works was doing in Marin County. This is what it used to look like. It was an impediment for fish passage. This is what it looks like now. So they did a rough and ramp. Marin Municipal Water District. This is what it did look like. And this is a constriction point. And that's what it looks like now. And I have the years, but you'll be able to look at that. So here's in 2003. This is 2006.
Wow.
Same site. And there's this. And this is what it looks like. This is just right after one storm. So this is the same year that was taken. So again, just showing the complexity around adding large wood, what it does geomorphically. It starts with the scour. So the darker the blue and the purple eggplant color is the depth. Again, this shows those two wood installations, specifically the creek constriction and the obstruction. And look at the difference right there as far as your change in depth. So again, summer rearing habitat for the pools for the juvenile salmonids. This is a project that I'm working on. I'm creating an alcove. So again, just a little off-channel habitat for the fish to hang out with high flow refugia. Devil's Gulch, Trout Unlimited. They put in a whole lot of wood in Devil's Gulch, a tributary to Lagunitas Creek. You can go hiking there. You can check these out. It's really great. They did this for really cheap. I don't even know how they did it. It's mind-blowing. Private property owners, this is what I see all the time. Bank failure, bank failure, bank failure. But then I get really nice property owners that I go out and I do a site visit. I give them some instruction. And then they do this and they send me photos. And then there's this. Whereas like an 80-something-year-old couple that thought it was great to remove some hypericum right before a storm event in the headwaters of Redwood Creek. So I went out and cut out a bunch of burlap sacks and used tarps to try to keep the exposed substrate from going into the creek. And the next weekend they followed up with a more permanent fix. This private property owner is great. Came to one of my workshops. This is his bank. This is in Fairfax. He took a picture of the tools that he used just to show me like what worked for him, which is really cool. And this is what it looks like now. And this is all new sediment accumulation right here. So all of that's new. So he's got all of that nice. And then he took a picture just for this presentation and sent it to me of his willows that are alive. So they're keeping good. Politics, this is where I got up to the end of my presentation and I was running out of time. I would love to say more about this, but basically what's going on with politics is going to dictate your funding and your funding sources and being able to do that. All the drought, people, there's different things that you can complain about and finally your politicians will hear you. Something will happen, some kind of assembly bill, Senate bill happens, and then there'll be funding that you can actually apply to, like I'm in the middle of doing for Prop 1 right now. It's not fun, but there's money.
And there are organizations that sometimes seem so out there, like the Open Space Council. They're the ones that lead a charge. So they have the people that put these together, get them through, signed, sponsored. It's one of those organizations, it's not just a club. They're really moving forward and doing great things. So
last but not least, what have I learned? I thought this was really funny. Perfection in every detail, this home. It's on Deer Creek, this is up in Nevada City, and creates the ambiance prevalent throughout, architecturally designed to embrace the creek. I laughed so hard. I'm like, who says that? Oh my gosh, this is ridiculous. So anyway, be patient, but be active. Mediation and facilitation, I can't say this enough. If you're not a people person, fine, but if you can somewhat deal with people, get trained as a mediator or facilitator. It's going to save you with getting projects done. Waterways are dynamic. There's no such thing as a house that can embrace a creek. Not in my experience yet.
It's the other way around.
Yeah,
The creek embraces
the creek will embrace your house, and you better be ready to swim. Private property owners would do more restoration if they only had help. So educating whenever you can, even if you feel like you don't know something that well, share what you do know, and admit that you don't know at all. And then hopefully something will catch on, and they'll be able to work with you. Resources. I wasn't able to bring all the books I wanted, and that's okay. So there's a lot. And as I mentioned to Kate, I've got a Prop 1 due on Wednesday of next week, but the following week I get to have my life again. And so I can follow up with some more titles to some of this stuff and some links. And of course you're like, what's TBWC? So that one didn't get cleaned up. Volunteer opportunities, there's a lot. So email me to get on the list. I've got my cards right here that we can pass around. This is a 3-spine stickleback. It's one of my favorite fish. They're really cool. They're anadromous too. They're so cute. And, oh shoot, the quiz. You guys are gonna get quiz. Anyway, we won't go through these questions, but I will at least ask, what's this one?
No, the steelhead's
Steelhead's the one in the middle.
Steelhead's with the
Steelhead
stripy.
is a red stripe.
There's a steelhead. It's got. I guess you can't see the dorsal
Is
spotting
that
too good, but you
just,
see that.
That's both are coho.
I tried to trick you.
Yeah.
Yeah, they're both coho. Top and bottom, and then steelhead here in the middle, but that big eye and that sickle long anal shape. Here's some little red action, having a good time. Get to see all these little guys. This is a Trica granulosa rough-skinned newt, and here's the nymph of a dragonfly, the Odonata order, which is really cool. And here's a red. So if you're ever walking around the stream in the wintertime and you see this open clearing, see everything's all kind of mucky, dirty, and then there's this clean area. They clean the gravel. That's what they're doing with their caudal fin, is cleaning the area from any fine sediment. And so thanks. So now you have my contact information, and with your packet, there's the first thing that's in there is Department of Fish and Wildlife. It's kind of a flow chart on restoration. There's also a document from Regional Water Quality Control Board that talks about their permitting, and it talks about other agency permitting as well. That's really helpful. It's called Stream Maintenance and Enhancement Projects. The emergency project process is in there. We didn't get too much into it, but this is a really great guidance document that I created just to help me understand the process, because all the agencies didn't even understand their own. And so I created this, and now they use it to train their own staff. So it includes all the different agencies in there. Common willows of Marin County, which are also applicable here in the Bay Area, in the East Bay, so that's really cool. And then you have the schedule for the native plant classes. They're free. Shoot me an email and get on the RSVP list, or just get on the list there for other opportunities. And then Marin County Watershed Contacts. So if there's anyone that you want to harass, ask questions to, follow up with, check out some of the plans and publications, resources. That's what's in your packet. And last but not least, Asphalt Ecosystems, primary and stream restoration from Ann Riley. Dr. Ann Riley advises all 9 regional boards. She's awesome. She's here in the East Bay. She works a lot with Friends of Sassel Creek. She's kind of partially retired nowadays. If you
What's
could
her
learn,
name?
Ann Riley.
And Riley.
If you could do
Okay.
soil engineering with her, she is like the guru. And then you guys probably already aware of this one, the common riparian plants California, maybe not.
No,
Okay,
not really.
so
but
too bad it doesn't fit in your back pocket, but it's really great. And it actually shows you like to scale how big. Actually has like photocopies of what the leaves look like. So that's a really cool one too. Okay, I'm done. Sorry.
Thank you, Sarah.